right. How y'all doing? How are you all doing? Let's have a look. Okay, we're good. Hello, everyone. I am going to engage in some rather boring activities now, which is rewriting some code to see if I can understand it. So, yes, this is going to be difficult. Now, the hardest part with this is that I don't know how it all hangs together. Now, there are, of course, a lot of... man, I'm losing track on who's who. Honestly. It's all right. The hardest part is tying all this together, but the complexity of this is too much to fit in one head. At least in my head. So, it might seem trivial to just do some value resolution. However, what makes this difficult is that we need to be careful with how we assemble the values, right? See, we already have, when it comes to lookup, we already have this. This is problematic. The left-hand side of an index can be so many different things, including an index, because the values are nested, right? I wonder if we can do this better. I wonder if we can do this in such a way. Well, we do have to deal with all of these, but I wonder if we can get this out of here somehow. To do that, we need to know what the deal is with list and map. So everything should come down to calling a lookup. We know that the right-hand side is always going to be the index because of how this works. The way the expressions that makes up an index is, it's always going to be the left-hand side and an index. Now, the left-hand side might in itself be a list, which in itself might be a list, right? So the complexity ends up on the left-hand side. The right-hand side, that's just the index, right? So can we circumvent this? How could we get this outside of the index? So the only thing we deal with on the index is a left-hand side and a right-hand side. So like this would be the obvious ideal situation. That we end this here. Like so. That is not correct. Unexpected close in the limit. Where? That one matches that one. That one matches that one. That looks right to me. There we go. Okay, so that has failed. So we'll get rid of this then, shall we? There we go. Right, so this would be ideal. So the left-hand side is not going to be subject to a lookup, but rather a eval. So we need a resolver. That, whoops, should be the left-hand side. In that case, why don't we attach the lookup on the resolver instead? Lookup. Then we can store the scoping and the states on self. Then that has to be for the scope. Not loving that. Okay, so, well, let's chuck the scope in there. We can rename that one after the fact. Or after we're done, rather. There's no facts here. What is the issue? Oh, right. Okay. So we need all this to be able to do this, right? We need all the scopes in the states and the globals. Scope level seems like it should be the first one. So then the root one is the same minus the scope level. Like so. Okay. No, not okay. No, okay. Okay. We have globals in two places. Gotta get rid of that. So scope state globals. Scope state globals. Wow, okay. Not loving that. So then from here we can do self.lookup followed by the expression. That will be better. Okay, then we move all this code into here. Lookup is just gonna do it on the right hand side. Then this thing can simply be self.resolve. Don't need any of that. Don't think we'd need that either. All right, we got double globals in there as well. All right, what are you complaining about? Lookup should return what? It should return a value. Eval value. Like so. That's going to be a self lookup. And that's an option. Okay, we'll unwrap that one for now. Mismatch type. Well, this lookup is no more. The relevancy is gone. We need more information here. We need scopes and states. Still not happy. Okay, now that makes sense. So any other expression is technically unreachable. So we'll express that here, unreachable. Lookup only handles ident and index. So that one is okay now. Oh shit. There we go. Hello, Dottie. Yeah, this is gonna be fun. In the sense that, you know, it isn't. Now, in an ideal world, this would be possible. If we can do this, then we can circumvent this entire catastrophe. But there's a reason for this catastrophe. But it would be nice if we didn't have to have it. The thing is, Dottie, I don't know if tomorrow will be good. I am worried that this is going to send me back into the anger zone. And I'm going to want to quit this project again. Because that happens at least once or twice a month. Hello, Christy. Load common val. Yeah, I don't think we're going to get around this. We kind of have to load up the index, and that is going through these hoops here. Are Y burning? I don't know what the state of Y is. The right hand side is always the index ident. Now this might still be in operation. A+1. So the expression has to be evaluated before it can be used as an index. That makes sense. I'm not burning anything. Hopefully. I do have large quantity of ice water. Should anything catch fire, I can at least be comfortable while it's burning down. Okay, so we resolved the value. Now this thing has to be... What could this resolve to? What could this resolve to? It can resolve to an eval value. Oh, and the whole expression thing is coming back to me now. Right, so we got a test case set up here for this. So this one's supposed to be a state lookup of an ident A. So we end up here. Now, if this thing, more problematic is that we cannot simply return, hello, we cannot simply return, I guess we have to return a dine for that. Is this alright? I don't think it is, but we'll start with that. No. Star Ocean? No. I have no idea what this is. This could very well be something from the 90s, couldn't it? Certainly isn't Star Tropics. The Magical Quest starring Mickey Mouse. Oh man, I have no idea. Basil something? It is not Battle Chasers. It's none of these. Nah, I don't know what this is. I have no idea what this is. I have no idea what this is. 2011. All right. Okay. Your favorite game, I see. I have not ordered it yet, Panosa. But I don't order it myself. It's something that my wife buys for me every year. Okay. Can we fetch the state as a dine value then? Okay. Unwrap on none. Okay, so that means that we're heading in a direction. So if the ident happens to be state, then that should be the right direction. Still don't get it. Okay, so that is not happening. Well, then we can start the debugging process now. then we can have a look at resolving. Okay, we should resolve the value first. That should give us the panic that we're expecting now. Yes. Okay, so it's as simple as that to get started. So now here we have to load the state that belongs to the current scope. So we have to ask self.states. We have to do a lookup here. No, not new. Is there no state lookup? This might not be available. No, it's scope lookup, not state lookup. There we go. So we're supposed to pass in the path. And in this case, the path will simply be a static string. So that's fine, right? And our current value ID. So this one is easy enough. So this will be... like that. Can we not do this? Yes, we can. We can't call into. Interesting enough. Now that we have the lookup, we can do ourselves.state. No, scope. Get with the lookup. All right, so get. Okay, the offset thing is really not great. Offset and then states. What do we call that? Scope level. Okay, so that one's an option over usize. Okay, why don't we just pass none in here because we haven't actually built anything up yet. Like so. And this thing should give us back an eval value. So why don't we just unwrap here? So we should now be able to get there. So technically this should be fine. But it isn't. Alright. At least we can chuck a debugger at this thing and see where it goes. Oh bollocks. Did we fail to resolve that? That can't be right. That would imply the states are empty. Okay, now we should come back up here to an ident. Yeah, that's our lookup. Huh. We do have a state. Well, then I am as confused as the next guy. Oh, it has a state ID of 5. Oh, shit. Morning, Nanaka. It's going. How did we end up with the wrong state ID? Okay, let's just get ourselves some debug info. Okay, no, of course we can't do that. How come we have an incorrect state ID in there? All right, well, I guess we just have to back up to look at the test. We store states in here. We insert the states there. Create an expression. This is always 0 for the state ID. Insert value. Lookup uses state ID 0. Really? Scope insert state. Where did the 5 come from? Where did the 5 come from? Okay, well, we'll try again. Okay, that's just pointing to that. Yeah, that all looks fine. I don't get this. What the actual what? Is this even right? As in, was this entry correct? No. What the? I wonder if the memory is not... if it's inaccurately represented here. Yeah, none of these are gonna fix the issues. Okay, let's see where we do an insert then. Maybe that will help. So we start off here. That certainly has an ID of 0. So I don't know what is going on there. Okay, so this is fine. That is certainly okay. That is not 5. Nor is it. That's the state. Oh, Nelly. Yeah, so this thing is not returning the state. How you doing, Tim Boris? Good, good. Okay, so if we get a state from a current offset, so really we just have to work backwards from where we are to find the nearest state. But currently we have no, if we have, well, it's always going to be a state. Even if we don't register a state with a component, there is always a state, the unit type. So we should start from the bottom. So we can always return an eval value here. We just have to start from the back of the storage. That's not entirely true. Okay, so we can do that. Now, let's bring up the oiter. The tier. All right, thank you. That's not the one I want. So it's just gonna be the slice iter for a back. What is this thing then? What's get do? Huh. That works on an iterator? No, this is a slice. Alright. Okay. No, I want the iter. Huh? This gives us an iterator back. And the implementation of iterator for this. That's what I should have clicked on. It's going to be that kind of day. So we can do a find. Right. All right, so that's an entry. Actually, can we do a find map? Is that a thing? Yeah, it is. I guess we could just do that for the option. Like that, okay? Have to dereference there. Man, sometimes I wish there was like an auto deref in Rust. Hello, Modprog. How you doing? Wow, I have no idea what you guys are talking about now. Okay, so where do we leave off? So that's gonna be the state. Maybe we can just do this. Really? Where is then? So it is that thing. Okay. Right, there it is. So this is going to depend on the lifetime of states here. Because that's what we're getting from, right? I guess this could have been used as one of the basics of lifetimes, as an introduction to lifetimes, but I don't care about talking about that today. I don't care about talking about that today. What a phrase. All right, so get state. We can now go back to expressions 2. And then here we should be getting a state somewhere. Where is this thing? Yeah. Can't do this. Come on. Come on. Maybe we can take a page from sort of the visitor pattern, right? So we build a new type around this instead. But no, we're supposed to return a value, so that doesn't hold. And on that note, there's nothing preventing you from just writing state. That could be something to implement state. Thank you so much, Caleb. Thank you so much for that. So technically, you could just write state in the... you could just write state in the template. And that would actually be nice if that worked, because then you could say that state is just a value. So you could just pass a value as a state. It's a new Discord thing. I know they still want me to give them my credit card details and stuff. I think that's just that's just a way now for Discord to be sneaky spammy. Thank you all the same. It's like, here's 2 weeks, but you have to give us your credit card detail, and I have to choose if I want to subscribe monthly or yearly. Okay. Yeah, so technically calling state should work. So I might have overthought this instead. So get state could return an eval value then. Question is, what does that look like? How do we get this into a dyn value? Well, hello, Pepper, how you doing? Welcome, Raiders. Okay, so we need to get the state. Now we have to convert this into an eval value somehow, and that would be a value ref. And the only way you can do that is to do state dot value ref, maybe? Not even a little bit. Well, there's a state get, but nothing else. Nothing good, Pepper. I'm just doing a really boring chunk of work that I started yesterday in an attempt to solve the big underlying problem. Every moment I'm working on this thing, I get more and more convinced that this is the right thing to do. The predicament, of course, is that this is touching on so many things. We might simply need a means to convert south into a value ref. So that would be a new function. I don't know if this is going to be possible. Now we need this on the state. And if we can make this happen, then we're good. Okay. Okay, so this is a pretty invasive change. I can see that from the 26 error messages that we have down there. How would that... So that can only work for something wrapped in a value. thinking this is not the right thing to do. Okay. We cannot do this. This only works for value types. Technically, we can. It just means that every state has to be wrapped in a value. But we can. So hang on, that's kind of important, isn't it? Every state has to be wrapped in a value. If it is a... It would be really nice if we could just say that our state is just a value U size, for instance. That would be really nice. But that changes things a little bit. This is quite a big issue. So all these states that we have for colors and what have you, I don't think they can exist. Okay, this will be an insane breaking change if we do this. Okay. Expressions RS, it touches everything, specifically to do with the values. So why is this so complicated, right? I'm doing a terrible job at explaining what I'm doing, so bear with me. Right. We have the state implementation for a bunch of types, which is an incorrect thing to do, I have come to understand. This should be broken into to and from common val and something else. Then we have the state itself, and that should always be a value. So if we do that, so the reason why we never cared about the whole value malarkey was because we wrote the state into a storage and we didn't care if it was wrapped in a value or not. That wasn't relevant. But if we do this, then we can say that state is always a value. Anything that's a value can become a reference and what have you. Then we don't need this. We don't. This trait, this type here is kind of wrong. I don't think I can make sense of this. I'm sorry. It's just not. This is what we're after. Okay. This is what we're after. And this is just outright weird as well, right? Because this brings us all the way back to value. And value is a complex type in anathema. Value allows us to have references to values, representation of references to values that may or may not exist, right? Almost like a weak RC if you squint a lot and you have no functioning eyes. But this will allow us to write values into storage. We can have references that points to this storage as this storage might have been drained. We don't know, right? But we have the suggestion of what could be a value that we cannot mutate. So we have these immutable values that can only be mutated through the state. But now I'm wondering if maybe we need to separate these two, and that's going to be a very, very big change. So we're saying that state can be anything that implements two common, but every state has to be wrapped in a value. We already store states in this state storage, right? So we already have that. There's a lot of casting, but that's no here nor there because we do the same for everything, right? But there's no way we can call two common on the state unless the state is simply a value. Okay, now that's a thing to solve. It would allow us to do something a lot nicer. So we would be able to do things like register a component with some component and then value usize. Like that. So that becomes the state, right? That would be a lot nicer. So when we make any changes to, so this would then be a value over usize. So when we have any changes to state, we can just do that, right? Now this should complain because, well, it complains because we broke everything, but that would kind of be good. That would kind of be good. However, this would mean that for our main function, actually let's take that out because I'm broken enough now. For this thing, this would have to be a value. The board would have to be a value and stored as a value, not as a state. So we don't really care about states and values. The only thing is we couldn't represent a board as a singular value. It would have a zero representation if you try to print or just use this board straight up. This is a very invasive change though. Like monumentally so. But maybe this would clear up a lot of the issues that are around value access. If we can simplify value access, that would be pretty good. But this is a massive breaking change. But it would get rid of states. I simply don't know what to do. This is too complex. For the end user, technically, Dottie, this change I'm talking about now just means wrapping the states in a value. So value new, board new. That's the only change from the end user's perspective. But it's very invasive because the value and the state are such a core part of the system. Or more, this would just translate into that most likely. Like so. But it would allow us to have unnamed values as state. It would allow us to have unnamed values as states. So we could say, you could just put a Boolean value in there. You could put anything in there in that case. Actually, we wouldn't even need to make a change here. We wouldn't need to make any change here. There would be no change for the end user then. Exactly that, Skylar. The difference between value and state, if state turns into value. So value is how we store things detached from where they seemingly live, right? So if we take this board here that has an X and a Y value, there isn't actually anything like an I32 on this board. These values are signaling ownership of two I32s, but they actually live somewhere else. If we sneak a peek into value, we might see this, which is why this thing just do that. What is actually happening when we create a value is that we take the value and then we associate this with a storage somewhere. But didn't... So we are implementing state for value already. So this is technically already there. The alternative would be to have a state ID as an eval value. Like that. So we just represent this as a particular state ID. Meaning no lookup has to be done through the scope. Maybe this would be a simpler start. Then we can go here and get rid of that and that. The debug writer is easy enough to fix. Well, since we're not going to use it right now, we can just do that. copy is simple. This requires access to states. Okay. All right. Oh, what do you want now? Okay. But that is... Oh, it's a value rev. So that becomes... Dine. Okay, then. So far, so good. Downgrade. This is an easy fix. Upgrade, on the other hand, is not. Well, yes, it is. That was a very simple one. Oh, fiddlesticks. Okay, so then this doesn't work now. Okay, so we cannot actually load a state when we call load common val. We could get around this by moving states. Too much water. Okay. What are you doing? Bunny's freaking out up there. Okay, if we do this, then suddenly we lose track of states. We can't load the common val. But we can come back to this. There are means of solving this. For instance, like moving the state storage into the rest States don't have to be separate from everything else. We could literally have states here. And that would solve that. Okay, let's go back to expression 2. So this gives us that eval value that we're after. It wouldn't even do that, would it? This one, actually, it would have to find the entry, and that's the state ID. So we'll return some state here. Actually, no, we would return eval value state. Then we can get rid of that and that and that and that. Okay. So now I just feel like there's something not right here. But okay. So we get the state. That's our eval value. Very evil. Get rid of that thing then. So we should be able to do this now. All right, let's panic with the result then, shall we? Okay, so we're failing to look up the right-hand side. We shouldn't be doing that, should we? Okay, let's put a breakpoint at it. Okay. So this is now empty. Okay, so how do we deal with that? Actually, we shouldn't look this up. We should resolve this. Hopefully that will resolve correctly. This is now state. Yeah, great. Thank you. And that is an ident, yeah? Yeah, it is. I'll tell you why this is so complex, right? We have values that are this complex type. Then we have things like expressions, which may contain sub-expressions, right? So expressions could be a collection of expressions, which is why we need things like RCs in there, because we need to be able to cheaply clone these expressions, right? And then we have these resolutions, right? So if this is an index, right, that means that the right-hand side is going to be an ident representing the key for this. But it could also be an expression, like a plus 1, which should resolve to some numerical value that is used to look up a collection. But if it's a map, then we want to use the ident as a key. The problem is we don't know if it is a map or not. And technically, that's irrelevant. We just need to create a path from this. But it becomes a little bit grody if we are going to look at the expression for the right-hand side first. So we end up with something like the right-hand side is equal to match on the right-hand side. If this is an expression ident, then we want to make a path from the ident. If it's any other expression, then we're gonna do all of this. However, I'm reasonably confident that we have a lifetime issue here. And we're gonna call this thing index. Wait, what? Oh, what a freaking surprise then, is it? Although technically this thing should be a number, so it's not really a common val that we're interested in. Oh, it is, but we want to get a straight up number. So we want to do load number here. So then this is a to int, no to int, as int. Okay, sorry. Then we can do a path from index. Is this pretty? No, it's balls. This is, but that's because this is the only thing that we can have. Either we have an ident or we have a numerical index, right? There's no other choice for this. And what are we panicking on here? The value ID. Well, that's easy. That's going to be self.subscriber. There it is. Okay, that's the first step. It is also the easiest thing to solve of what we have solved now. The problem is more prevalent once we start adding more complex types in there. But we have now done our first successful state lookup. So technically, this should now pass. All right. We have successfully done this. However, because things aren't that simple, we're gonna get the worst now. We're gonna get the absolute worst here, I think. All of these are pretty basic expressions. Simple lookup. Okay. Yeah, that sure was a simple lookup. Index lookup on a list of maps. Now this is more complex. Let's grab this thing. Okay, now we have to read the test. So we're gonna have a map that contains a val. So this is our first thing that we have. Then we're gonna have a list of these maps. I'm going to push back the map. So we now have a list of maps. Then we're going to register this list of maps under name of list. So technically, we should have to do one more jump here. Not even interested in adding. We're going to do an index with an index here. So that becomes an index with an ident of state followed by an index. Oh shit, no it isn't. This is placing it on the wrong side. It's here, ident state. Good grief. Unpack this thing. But remember that the right-hand side is always the index. So technically this is fine. Then this thing is the right-hand side of that, and then this number is irrelevant. Okay. So the first index we have is the state and list index. The second index is the first index followed by the number 0. And the third index is the string literal val referring to the key here. So this thing should technically be 1. No, it doesn't even compile. Come on, man. Expected a lifetime, but no, it doesn't. It's because it's referring to the wrong value. That's all. So this should be do we have the values in here? There we go. Okay, so we don't have a string literal in here. No. If this thing compiles on the first run, I will be very surprised. Not yet implemented. I'm gonna give that a 2 so we don't actually run the same test as the other one. Unwrap on a non-value. Okay, let's make sure that this thing is correct. Okay. As beautiful as this is, our index contains everything has to be shifted to the left for this to work. The right hand side is always the actual index. Okay. Right, then let's just see where this thing fails us. 75. Apparently not. Well, breakpoint time. Okay, so that's an integer of 0. Okay, that one's correct. That one is a common stir vowel. Shit. So much for that being a number then. Can we call it an ident and just move on? Holy fiddlesticks. That just freaking worked. This can't be right. And why can't this be right? Because of the amount of code here. Look at this code. And then you look at this code here. I have to shrink this a little bit so you can see it. This is the code that we're replacing. Sorry, can't even fit on screen. This code here is what we're replacing with this. Sorry, it's this even. There's no way this is correct. There has to be something wrong here. And half this code is a comment. So what's that? Do we have a string literal here as well? Yes, we do. So can we go back to calling this thing a stirlet now? Damn right we can. Damn right we can. Okay. All right, let's see if we can find some more complex test cases then. Index lookup on a list of lists. Let's take this one then. So this one tries to perform some kind of operation on there, but it's not overly important that we do that. So we're not going to subtract anything. We're going to change this back into... You can just write out the indices, right? So this is a list of lists, which means we're going to go from index. That has to be an ident of state to index. This is the first. There's another index in here. So that's our first one. That's a second one. then this can go. Just clean that up. So what do we insert into the list? 1, 2, and 3. So we should be able to get 1, 2, and 3 out. Damn. Damn. Okay. I think this is the most complex one there is. However, there is no way that there isn't things that we are missing here. All right. What about future values or value changes? Well, that is the next thing to look at. So this was a bug that we had in the past where changes were to happen on either of these. Which would not reflect in the template. And I do believe the same bug is present now. So how can we write a test case for that without having multiple states? The simple answer is we can't. Okay. Where either of these two numbers were to point to an ident, that technically makes this one wrong. The Sterlit part is fine. Let's have a look at this thing. See here, we never really care about the right-hand side being anything. We just say, load this as a common val. We are resolving the right-hand side though. And for some reason we're saying that it's okay that it's empty. So it has to be possible to express this. My map some key like that, which should then translate to my map A. I don't know why anyone would ever do this, but technically it should be possible. We should allow for multiple states. This test case was designed for something specific. Should we make the old tests pass before we move on then? So let's take a simpler test. Okay, we need to bring that in. Not yet implemented, 46. Okay, so here's all these expressions that we need to, well, we need to implement them, don't we? Okay. Oh. Wait, that means that the list was never tried. Fine. That's gonna be one of the issues then. Let's just do a lookup on a static list. Then the expression, can we have multiple expressions? No, this is rubbish. Okay, it's the... We don't have a means to have multiple expressions. We don't have any means to test attributes either. I wonder if this test, the scope test thing, is actually quite bad. And we need to make a new one to try all this out. So they're convenient enough to read, but since it only allows for one expression, well, technically we could make more expressions happen. Maybe we do that first. Like that, and then here we'll do that. And when it comes to evaluating this, yes, where does that happen? There we go, right? Oh, crap. How does this help us? It doesn't. It does not help one bit. Freaking complexity, I tell you what. And we don't even have globals. So we don't have any means to test globals. This has to be rewritten then. But why don't we load templates then? Maybe there are better test cases we can build this on. Because we have access to the template loading. So we can do that now. It would actually be the more sensible thing to do, to load the templates and load the state and then run this. So let's have a look at testing. So this is doing a test against the tree. Doddy, was it you who wanted to do a test against the tree? I think this might do that for you. Yeah, what is it that you wanted to look at, Doddy? You were interested in being able to run a test and look at some output, weren't you? Maybe not. I don't remember. Can we use these test cases here? Okay, so what would be a nice looking test case for this thing? It would be if we could have a test case new. No, we want to evaluate expressions here. There is so much complexity around this. What if we could do this with states? And then... But then, yeah, that's the problem, right? We have to be able to load things into globals and stuff to be able to test all this. Okay, what does our current expressions look like? These ones are simple. This we could effectively copy. Although I'm not sure why the function calls are ending up as invalid idents, whatchamacallit. We never get the function call. Let's not even worry about that now. Where's the resolve function? Here it is. That one is already done. Values. Stir is done. Map is not done. And list is not done. Okay. Is this right to resolve every expression? And then resetting the offsets, that obviously exists for a reason. We've done the lookups. Okay, let's get into conditionals then. That's going to be here. Not equality and negative. Negative is not a conditional. So that's not an equality done. Okay. Right, that's op done. Either this is new. Well, that was also wrong, but okay. Then it's function calls. Okay. Don't need any of that. Don't need this. Certainly don't need any of that. This reset offset thing is definitely gonna bite me. Okay. So that's all the standard stuff done. Why are you failing now? Well, actually, this is an index with an ident of state and A, and an index with an ident of B. There. Okay, so this technically is working, but the difficult aspect of this is not working. What do we have anything that is preventing us from slotting in the second resolver now? Not really. We still don't have one for collections. But it's going to be too dire to actually try this out by running this against actual code. It's the answer. We don't have future value resolution either, but the future value resolution stuff is broken anyway. So I think we're going to... Well, it's not broken, but it's causing a massive slowdown at the runtime, even though I didn't think it would. Really just ice left in this thing now. Okay, we need better testing. Better testing tools. Okay, one of the things that we can see from here, so this isn't really an issue. I don't know if this is an issue or not. And would it be resolved? Well, technically this is wrong. That should look like that. But this isn't necessarily a number then. Fuck. No, we don't have that one yet. And this one doesn't work either. Need better testing. We need better testing. All right, before we rewrite the test harness, let's think this through, right? Let's compare this with our current expressions. If it's an ident, then we do a lookup, right? Actually, you know what? We're not done here. That was the hardest word to write. We're not even doing a regular lookup. So we need to get states. We also need to get attributes then. Well, not really. I guess we're just scoping the attributes. But we're not scoping them under something. And this becomes confusing because now it seems like you can actually create locals, which you can't, other than through a for loop. And if we do that, why not just have locals then? The only reason we have globals is for theming. Oh shit, if we start pulling at this thread, we get nowhere fast. Now, without testing, this thing is a house of cards. We cannot, right? Three. Okay, look up offset. Oh, God damn that offset. Okay. I guess what we could do with our scope is we could scope attributes, but they belong to the freaking thing. Right? So if we look at the eval for a component, here, we're scoping all this under attributes. We're scoping all these under attributes, which means that technically this should be scoped as an attribute instead. How hard would it be to solve the future values as well? I am losing my mind here a little bit. So this is scope attributes. This, we can scope them under an attribute flag, but technically what we could do here is refer to this as the component ID. So we can have scope component attributes, and then there's no binding, there's no downgrade, there is only component ID here. Widget component ID. And then this is gonna be just like state. This would be component attributes, widget component ID. Right? So we don't actually scope each attribute, and unnecessarily so as well. So this would just be scope component attributes, and then we need a widget component ID, which is, wait, do we have this available somewhere? I think we do. This is probably a widget component ID. Fuck yeah. All right, component ID. Get rid of that bullshit. Of course, how do we resolve these now? We can't. We can't resolve these because they don't freaking exist yet. Well, they do, but they don't. Ah, the joy of nonsense. So we're gonna scope these things, which means we need lookup fields for these things. We need access to the widget component whatchamacallit. So, okay. This means that we're going to have to add things into the... Look, we're going to have to solve that anyway. Like, to load a common val, we're going to need a bunch of other things anyway. There is one more place where this thing would happen. Let's find the scope downgrade thing here. What is this thing? It's a for loop. Yeah, in the for loop, it makes sense. Update. Here we are. Component. As long as we can use component .component_id, we are good. We can. That makes this faster as well. Given that you probably don't need all those attributes anyway. Okay, I think we're winning now. No, but okay. So we can at least distinguish between attributes and state now. They are two different sources. So let's go back to our second set of expressions. Again, we certainly need that thing. So here we're going to call get state. Instead, we're going to do get component attributes. Wait, this makes no sense. Why are we making a lookup? We're getting the state. We're going to get component attribute. This will be very similar to the state. We're just going to fetch the attributes from here. Okay. Copy, copy. What could go wrong? No, it's not attributes. It's component ID. Okay, so let's go through and fix this then, shall we? That doesn't have to exist now. Yeah, what is the problem with that? Found the unit. Does this not return an eval value? It does not. How you doing, cat peasant? here's where things are gonna get a bit ropey. That does indeed seem to suck. Cap hasn't worked, sort your shit out. All right, so we need to get access to the storage for the attributes here. Okay. So this is where we're gonna have to make some changes. Really? Is this the only place where we have load common val? No. This is everywhere. Okay. Hello. Okay, so better testing will make this work. No, better testing will make it possible to see how fucked this is. Excellent. Okay. Let's see where the scope test is actually being used. Here. Okay. And in testing. All right. Fine. It's not too bad. Then I'm going to make some tea. See if we can leave half my hair in my headphones. And maybe nothing. All right. Kettle time. All right, let's see. Some tea is a brewing. Okay. Better testing. That's what we need. And to get better testing, we need to be able to load multiple expressions. We need to have the ability to test almost on a frame by frame base. We don't need that. We need attributes in there. What else do we need? But then this isn't really helpful. The test is too weak. It needs to be more extensive. Maybe the test should be moved in that case. We need the whole component registration. T is always good, Scott, except when it's not. Oh, man. This is a day. This is a day. Okay, so I've introduced 2 issues, and maybe I should focus on solving those. We already know there are issues because we can't load values. The only way we can load values now is through the through here, right? So this is a problem because these 2 won't work. Can we find everywhere where these are being used outside of this project? Nope. That was not useful then. We know internal stir iter is being used inside the default widgets in the text. Here. Tea's ready. All right. Okay, so we got our caffeinated drink. Slowly dissolving. Producing a flavor of rotten lemons. Probably the closest we can liken that to. And we got some tea. We're ready to continue. So all of these things that we have to operate on will require access to things that we can't give them access to right now. Well, it tastes as bad as lamb sip, so close enough, right? But I need the caffeine. Well, I don't need the caffeine, but it helps. It helps a little bit, right? Okay, so I've broken this thing now by doing this. We have no means to request any further information. So we need to get that working again. It's a lot of we in these conversations, but I need to get this working again. By introducing state, we need access to states. By introducing attributes from the widget, we need that. Coding is fun. Stop breaking stuff. Can't help myself, Scott. Sometimes you need to break things to make them better. And in our case, we need this to make this better. But it is insanely complex, and there's no way of reducing the complexity around this, right? This thing has its tendrils in everything, right? So we cannot iterate over strings. We cannot have access to values. We cannot do any of these things if we don't provide more information. It sure is. Ugh. Oh. Not enough water in there. That's gonna take a while to get through. Whoa. Okay. So since we moved these things out, they're now dependent on the widget tree and the states collection. Two things we cannot access here. I don't know, man. Probably would have just been more sensible to not do it this way, right? But after this, there's no more big issues after this, is there? So this has been done. This is possibly done. It's waiting. This has been done. This is what we got now. And then we have a bug. Actually, it's not a bug. Future value resolution is slow. And terrible, but that's not it. It's slow and holds up. And causes bad performance. This is another one of those things that are just... We can't do anything simple with this, most likely. Ideally, we'd be able to report when a value is filled, but how do we know? Right? I truly, truly want to quit this project today. I know people are going to say, well, do something else, but that doesn't work for me. I don't have it in me, right? I can't just leave a puddle on the floor and say, I don't want to deal with this, and then go and do something else, right? So that is not an option. The only thing I can do is just keep powering through with this. And that's all. That's really all I can do to try to finish this. This might not be the right path to take either. I'd love to have that cat peasant. To have some kind of sliding window into text, multi-line editing, whatchamacallit, would be absolutely fantastic for this. It would basically be the core for something as simple as multi-line text input and an editor, right? The pants are staying put. Come on. And we're done. Oh my God, Dottie. Thank you so much for that. Thank you. I really appreciate that. That's very kind of you. Thank you so much for 10 gift subs. Thank you so much, Dottie. If I go and shower, then I literally just showered before the stream. If I go and shower again, I don't think I'm gonna have any better ideas. And what am I gonna do? Just leave the stream running, chair stream for 15 minutes. You want to solve these problems too, Danaka? They are definitely up for grabs. Now, this is one of those things that I would never leave this for anyone else to solve. This problem is too complex and too painful for anyone to have to deal with. I see you guys are going with the no pants concept again. That would be good, you say, but the scam editor needs code to run. Thank you again, Doddy, for that. That was really nice of you. Thank you. Thank you so much for the cheer. I appreciate that. I think this is the real reason one shouldn't do programming projects that spans more than a weekend. Yeah, but that's still well, I get not really, because Scammed won't compile now because I broke anathema. Warm tea. Warm tea is so good. The flavor is pleasant. It's not gonna blow your mind, but the hot beverage aspect of it is it just adds so much more to it. Okay, so I've painted myself into a corner, and I feel like this has to have tests to be resolvable. But we have the other problem too, which is this. How can we do any of this? Could we maybe do this through the context? This might be doable if this thing could have access to states. This will solve the first one. Shit, there's no states here. Where am I? Okay, we can pass the states in. Oh, it's the widget cycle. Okay, right. Why? Why? Come on. All right, let's do this thing. Wait. Right. Shit. We could just pass in a reference to states there. There's no reason to, but we are going to reborrow that. One down. Okay. Now, can we do this through I think we can do this. The next thing we need to solve is not states, but widget component ID that translates into the attribute stored on there. Unless we just store that as the attribute ID. I mean, we already have the attribute storage. Actually, that might be more problematic than not. We can solve this. This is solvable. If we can just get the layout context to give us the attribute, so we don't do it through here. Okay, how are we accessing these things? We get the attributes, but this could be a wrapper. So instead of returning attributes, we're returning something that contains attributes and the state and all that stuff, so we can do the lookup. I think this is fine. We just end up with another type. Okay, so since we can see a solution to this problem, we don't have to pursue this. We can make a comment here. All right, the problem is solved. Or rather, the solution to the problem is not too foreign. Okay, that brings us back to testing, okay? What is one of these heinous things that we have to test? So when something changes, so this one is fine in that case. I don't know what we're gonna do with globals, but a secondary map, that could work. That could work. But then why not just write them into the attribute storage in the first place? Because we cannot access the attribute storage for a component while we're accessing the attribute storage for... Well, we can, because it's immutable storage. Let's do that. Let's do that change. I'm feeling pretty jazzed about that. So let's go into our eval for our components. And let's have a look at the single widget evaluation. This one has new attributes written to it. Here we're using component attributes. So how do these differ? Attributes, are you a small map too? No. What does this return? We have values and a small index. That's because we have the notion of a value. So values are a small map, okay, with a value key. And the reason we have a value key is because it can blah, blah, and with the blah, blah, we don't really need that. We could have a separate storage for component attributes in that case. Maybe. Maybe. We have that. We don't need this, but that's kind of okay, though. Okay. So here we store the component attributes on the component, whereas we could just not do that. So we could just make new attributes here. Like we do here, right? And instead of using a widget ID, which we get from the transaction, like that, shut you up. Don't care about that. Do care about this. But the problem now is that we end up subscribing a component to changes, which we don't really want to do. That's a little bit shit, but that's all we had to do, right? What does this eval do? Oh, fuck. That's the pain. Ah! That's where the pain lives. So we don't use the attributes by associating the widget component ID. Instead, we use the widget ID. Okay, then. So let's get rid of this. There are no attributes here that we're going to write onto this component. None of that. Get rid of this. We're just going to use the widget ID for this thing. So when we create a component, widget ID, we need this. Okay. Let's rip all this out. There's no way that's a bad idea. No, you don't get to have that. So this is going to be funny. Okay, so what we need now is we need access to attributes, please. Fine. No, not fine. Not fine at all. Okay, we need attributes to be available here. So component context needs to have attributes, but do we store the attributes for... We have 3 errors here. What is happening here? Try resolve value. Who is using this? Future values. Fuck. All right. This should be similar to what we do. Damn. It's a for loop. The component doesn't have an ID. But you know what? Why don't you get yourself a widget ID? Like so. Fix it. Damn it, we have more errors now than when we started. Here we just have to pass in the widget ID. And that solves that particular error. Now, go to the next one. Oh, in visual mode we want. There we go. Okay. We would allegedly have to load up the attributes onto the component context. I don't think that's a problem. You piece of fiddlesticks. Okay, can we just cheat and slap that on there? This is a problem. So this allows us to only read the attributes. That is fine. Why is this thing complaining though? Oh, because we're using get. Fuck. What did the component attributes do in terms of get? Probably shouldn't have deleted that code now, should I? This thing needs to have... Okay, now we need to add attributes into this thing. Come on, you flip. Why do we need an explicit lifetime on the key? That makes no sense whatsoever. Honestly. The key does not have to outlive anything. No, this does not make sense. Rust, you're being wrong. Stop being wrong. The thing is, it's neither of these lifetimes. Well, that should have a lifetime of self. So this should be... This is already implied that it looks like this. I don't know why this thing is being a complete and utter muppet. You don't need an explicit lifetime on the key. What are you talking about? This should borrow this for the duration of self. Oh, you got to be shitting me. That is not it either. So we have to borrow K into Q, and then we can do a comparison here. But why would that be? Why is the lifetime on the key even remotely relevant? Yeah, why is this thing returning data with a lifetime of 1? Now that is not helpful. That is wrongful. Okay. Oh yeah, that has to be... Okay. We're mimicking this. Just calling base get, which is doing what? What is self.base? Oh, it's a base hash map. Thank you. So it's hash brown hash map, which is not in here. So that's gonna be the lib then. Okay, where's the get function? So here we're just borrowing the key. We're not borrowing self. Although I don't know if that has anything to do with the actual get function. It would be good if we didn't have the repository. Instead, I would like to see the docs for this thing. Okay, so it has the equivalent on there. So they do this equivalent key. They don't actually borrow on that one. So K is the key. Okay, so they don't do that. All right, let's see if we can untangle this. So why would K borrow Q have... It has no lifetime associated with it. There's nothing here. So if we said panic here. Yeah. Okay. So even that does not fix this if we just threw all that out. So that is not the issue. I don't get where these fucking lifetimes coming from then, right? Why is this lifetime even playing a role in this? We're calling get on self values. This key has nothing to do with anything. This is just an equality check. So this has nothing to do with anything. Even if we did this, this will not compile. I'm going absolutely bananas from this. This makes no sense. There is nothing here. Even if we took that out and say there are no references in this, Oh, you fickle bastard. Still the same shitting issue. All right. So we don't do component attributes here. No, we have to get the attributes first. Will you just not? Okay, well, that's fine. The component context does not have attributes. It has attributes, but those attributes has to be... Okay, so... We're not out of the woods yet. Because we just threw a panic in there. What is the lifetime of this thing? We can't see that. And this will just bring us back full circle. How can this key affect the lifetime of that? Let's just do this. Oh, not even a little bit. Oh shit. Wait, it's the get val that's causing the issue? What a move this was. What a move. The most frustrating part is that this key is probably never ever going to be used as anything but static. And here the suggestion is to do the wrong thing. How are you returning data with lifetime of 1? I don't understand this. How is that possible? The get function. Right. You do not need a type parameter. Thank you kindly. Really? Even if we get rid of that? This really makes me question my sanity. There's nothing here that has anything to do with any lifetimes. Why the flip would you need that? The key is entirely irrelevant, right? Pass ownership of the key if it makes you bloody happy then. Okay, now you're really taking the piss. There's nothing here that has anything to do with any lifetime other than self, which is associated with values. Values are... that's all they are. This is where I would say the compiler is wrong and I'm not, but the compiler doesn't think or care what I say, and clearly that isn't the case. But it is not clear why this thing has any impact on the get function of values. Why would that have any impact on it? Here, we can clearly see that we have a self, which means that this lifetime will be tied to this. Nothing else. Nothing else. All right? None whatsoever. All this data is owned by the small map. Even if this thing was an own string, it would have no impact on this. Wrong bloody function. Oh no, because this sits in attributes. Fuck me. You piece of shit. This has nothing to do with it. The lifetime of the key has nothing to do with any of it. As a matter of fact, this isn't even the right type. Why is this even compiling? This is a completely different type than what we have here. We're supposed to get a value key. Oh, is this the issue? Is this the bloody issue? Because the key this is the problem. I don't know why this thing compiles, because it shouldn't. we're passing a string. We should be passing a value key attribute. However, this makes sense because we now have a lifetime associated with this string slice, which subsequently means that we're borrowing the thing for the whole fiddlesticks. So this technically has to have a lifetime of blueprint for us to be able to do this. Are you shitting me? Right. But this isn't right though. We need to be able to compare a string slice with the value. That's why. So this is all hokum. It's all nonsense. Where was that? Oh, wow. Do you think we have enough files open? Where's the get v2? Here. So this sadly makes sense. But we're supposed to be able to borrow the key and do a comparison here. But this borrow is going to have a different lifetime. We could maybe change this to an asref instead. String ID. What? Oh, yeah, that makes sense. We need a borrow implementation on this key for the value. For the value key. Where does the borrow implementation come in, though? Get out of the source. Why is borrow implemented for value key? It isn't. So when we do a get here and we call borrow on the key, okay, no, there's no borrow implementation here. I don't get this. Where is the implementation of borrow for this thing? I see what the issue is. I just don't know how to get around it. All right. It's common to provide different representation of type for different use cases. For instance, storage location, management value can be chosen appropriate for a particular use via pointers, such as box T. Beyond these generic wrappers that can be used with any type, some types provide optional facets, providing potentially costly functionality. Example such as type of string, which has the ability to extend string with basic stir. This requires keeping additional information necessary for a simple and immutable string. Right, these types provide access to the underlying data through references to the type of that data that's said to be borrowed as. Okay. This is not implemented anywhere. When providing implementations for additional traits, it needs to be considered whether they should behave identically to those of the underlying type as a consequence of acting as a representation of the underlying type. Generic code typically uses borrowed T when it relies on identical behavior of these blah blah, likely blah. In particular, blah should give the same result as blah. If a generic code merely needs to work for all types that can provide a reference to the related type, it's often better to use as ref, as more types can safely implement it. Yes, but how? Where is the implementation of borrow? Right? Where is this? So values has a key, which is a value key. I don't see any borrow on any of these things. How does that even work? K has to implement borrow Q, but that's not anywhere to be found. It should be impl borrow stir for value key. Probably can't have that, but let's type it out anyway, because why not? Does this have to be sized? No, it doesn't. Okay, so middle finger to this then. And it still doesn't freaking work. Where does that implementation of borrow come from? Right? I want to scream a little now, because the error message is now dumb. Why was this working in the first place? Borrow is also implemented through generics. Where? I don't see that anywhere. I thought borrow was supposed to be... Oh, come on. Let me search, man. Impl. Yeah, but where's the implementation? This is the definition of the trait. Where is the implementation? This will allow it to borrow self. But we're not looking to borrow self. We're looking to borrow into string. This is not... Yeah, this is not the implementation of a borrow from a value key for a string size. This borrow doesn't exist. So how was there ever an implementation of borrow for the value key? We're not passing a value key, are we? We're passing a string size. Fuck off. Where did you come from? Here it is. Here it is. The borrow was never implemented. Okay, that's better. So value key borrow stir is not satisfied. Get wrecked. Okay. I can't believe I was so blind to this thing. But there we go, right? What a complete kick in the eyeball. All right, but at least it stands corrected now. So even though we generated something with a different lifetime, we couldn't borrow against the same time. Okay, who cares? It's freaking done. Okay. All right, so that was a bug that has been in there since day one, but we never got the pleasure of seeing it. This thing should probably be as stir. Okay, right. What a train wreck. But now I forgot where I was in the first place. I think we had a panic somewhere. I didn't want to panic. Somewhere in the runtime. Okay, let's just open up the buffers to here. Runtime. Yeah, there you are. There is the panic. The guide is fine. I don't mind the guide. Attributes. So now we have to get the attributes out. Is this on the event context? Yeah. Now we need to get component widget ID to get that. No, there's no. Okay, so that gives us the attributes. You got to be shitting me. No, we can't do that until we have that. Ah, fuck! Good, Bean Juice. How you doing? How's your day? Okay, the alternative is to move the component attributes outside of there. Okay, so that's how it's gonna be. Okay. Put down the healing crystals now, buddy. You're making me concerned. Okay, so attribute storage needs to be mutable on elements. We need to keep separate attribute storages for the components. This is not the main driver of this change though, so we're gonna leave that one where it is. I'm gonna close down all these buffers and go back to the second incarnation of expressions. Do we have anything in here that is currently broken? Or can we actually try this out? And whoever's running these bots, you're a twat, and I hope you get fucking gangrene in your bollocks, okay? This can also not work because this is not guaranteed to be a number. This could be... Okay, but that's not the worst thing that we have to deal with. There are worse things in here than this. But we're not evaluating this. That's the thing. What if we did evaluate this? Then this is going to be a value. But it can be freaking dynamic as well, couldn't it? Okay. Just can the GPT chat, okay? That's just too... It just generates a bunch of bullshit text that is just annoying for people to read, okay? It doesn't add anything, right? It's just noise. Just go back to be your normal disturbing self. Ignore the whole LLM bullshit output, please. Okay, so we can probably get around the path evaluation for this thing. However, partial resolution of values. This is where it gets tricky. As part of getting to, well, it shouldn't be because we are using the value ID. We have no means of testing this. So one of the things we have to test is what happens when we have a value that points to an attribute that points to a state above it, right? Oh god, I need to eat some food soon as well. How does this differ from the other expression evaluation? If we were to move this code over to here, so according to this, we're always going to resolve the right-hand side value. And this thing, so this thing is kind of going against what the above comment is saying though, right? Don't need to register if this thing is empty, then we don't need to register. But why are we registering a future value here then? If we fail to load a common value, why should that become a future value? I don't know. Okay. It's fine. We're okay with that. All right. What is this doing for the left-hand side? Well, that was useful. That's an expression. Okay, that's so we don't have to reference the reference. That's just to prevent that. Right, so that doesn't really do anything. Whatever, right? And then here we do a list get, but that should just be, because that could be an expression of a list, but we can resolve that already into a list. So this makes no sense. How can you get here? If this thing is a map or a collection, then surely this should be resolved. I guess the advantage of doing it that way is a small performance bonus, given that we don't have to resolve all the values just to get an index, but resolving the values shouldn't be that expensive anyway. And I'd rather take an uncomplicated function over one that has slight performance boosts, but looks like something that's been hit by a truck. We kind of need to know where we are in terms of scope as well when we start resolving. That's going to be a thing. So this thing makes no sense. Well, it does. If this is a path index and this is a list of expressions, then we can just dig that out and resolve that. That's fine. So this is just an optimization. But let's see if we can be without said optimization. Maybe we skip global resolution for now. And we just deal with state and attributes. We're going to have shadowing happening either way. If you have a global value named X and you do for X in Y, then you're going to shadow X. It's just as simple as that. Okay. Right. Okay, should we just move this into... We could move this code into the lookup code of expressions then. Ah, fuck. Now the scope doesn't even sit on there anymore. Okay, you know what? Let's not do that. Let's get rid of the value resolver instead. It's called resolver 2. So let's just find value resolver. Hello, Andreas. How you doing? Sorry, Andres. What were you working on? So much bro science in that space, Monokuma, but if you want to listen to someone, at least listen to someone who pretends to be a doctor, I guess, instead of someone who's just making shit up. But they might as well be making shit up. As with anything, if you're looking at it for exercise advice and stuff, just try out the exercise. I mean, one of the things he actually says himself is like, you know, the things that we show you might not feel good to do, then don't do it kind of thing, right? Oh man, Andreas. Sorry, Andres. I know someone named Andreas, and it just keeps jumping there in my brain. I would have gladly done that. Yeah, I think streams doing that are probably more interesting for the viewers as well. It's not so much arduous grind, and no one like there's a handful of people in the chat who knows what I'm actually doing. So all right, now we have to throw in some more things in there. Okay, we're gonna do scopes and states in there. What else are we missing? It'd You're okay, Bean Juice. I normally don't mind it. I mean, you do you, right? I don't mind it. If I really minded your behavior, I think we would have a conversation about it. Scope states global sub. Scope states global sub. There we go. Right. So there's a really big issue with the core of this library, and I need to resolve this issue so we can have almost namespacing for certain values. And it's a really complex piece of code because the code itself isn't so complicated as much as it just touches on everything else in the code base, right? And now that makes sense. Let me know if this works for you. If this doesn't work, I mean, feel free to just ask questions, right? I don't think there's a lot of people who's gonna understand how this works out of the box, right? All right, so we are running into issues already, for better or for worse, right? On expressions 211. Here. So we're trying to do a lookup of something and it fails. That's okay. So we can do a match on this thing and just return an empty value. All right, so this thing will have the same match statement applied to it. Right. Okay, so should we do that change? So the whole thing stems from how we use the template language, right? So this is all commented out almost, right? But when it comes to accessing values, we should be able to, inside the A template here, we should be able to access values as attributes value, right? So we can make a distinction between what is an actual attribute and what is part of the state and so on and so forth, right? So this is panicking from probably the runtime, I think it is. Yeah. Where in the runtime? 47. Here. So this one really says that we have to move our attributes for our components into their own storage and not mix them up with the rest of the component storage. And that's fine to do. It just means that we need separate attributes for components. So if we look at how attributes are handled here, we have this cleanup thing. We do attribute storage. Here we're going to have component attribute storage, which is kind of crap. So let's not do that. Let's find the panic again. Hey, it would be nice if we could have... Well, if we store the components on... If we store the attributes on the component, then we cannot access these outside of the component, right? So we're going to have to pass this in. Unless we can do this as part of the build-up. Maybe we could have done that. So is this a mutable reference to a component? It is. And do we use this component anywhere? We do. But the question is, can we borrow from this component for the duration of this? Can we do something like ID is equal to component dot widget ID? And we're going to borrow this thing. We're going to borrow it mutably to be extra particular about the whole thing, right? And then here, we're just going to print out this ID. So this just tells us that we could borrow from the component context. So whatever we build up, we could include attributes from the component. So we could say component dot attributes. And we are just going to borrow these. Now, there is no such thing as attributes on the components. We're going to have to make that happen, right? So we had these component attributes in the past. We took them away. Then we're going to add them back in again. We don't need the widget ID anymore, right? We're going to have attributes. So we'll make this into component attributes. And we're going to grab our attributes that we had in the past. This is going to come from widgets. So we're going to jump straight into this project. Inside our eval function, we're going to have component evaluation somewhere in here. Here we go. So these attributes should be component attributes instead. Component attributes. We don't need to store the widget ID on there anymore. That would mean the template could not set an attribute defined on the component. You're not allowed to write to the component's attributes because they're given to you outside of your use, right? So if you want to modify component attributes, then you shouldn't use attributes. You should use state. Attributes basically replaces external state. Time for breakfast is practically lunch though, isn't it? All right, so we are going to make a pub struct component. Actually, we're going to do a pub type component attributes, which is going to be a small map with something in it. And I don't quite know what. So we're going to insert. This should just be the key, which is an RC stir. So this could just be an RC stir in that case. That's an RC stir. And I don't know what the value is yet. We're going to eval the value, which would return an eval value most likely. No, it returns a value. I don't know if this is what we had before. I guess it doesn't really matter. We're going to need this anyway. So we're just going to say that this is a value. But it's not as simple as calling a value though, right? This has a lifetime. And that will most likely be an eval value with the same lifetime. So now we can have component attributes in there we already have the lifetime here, so we're all good to go there. Can't be bothered with that. Can we get around this somehow? Without having to actually deal with the value evaluation, I wonder. Well, we have to resolve the value. That was always the case. And if we're going to resolve the value, we have to use a widget ID for this thing to actually work. Otherwise, we have no way of associating what is what. Although technically this means that we're subscribing to values which we do not want to subscribe to. Maybe they were all pending values, and that's what we did with this. All right, 1 second. I need to figure out some kind of lunch at some point. Okay, so well, here we could use the transaction. So that will take care of that. Although technically this key could just be, this could be, where is the attribute thing? There's passing attributes here. Then here we can change this to have a reference instead, like so. So we don't actually have to worry about it. Ah, fuck. What are we doing here? We try to resolve a value. We're gonna panic on that one. We no longer refer to attributes through here. We only refer to attributes through here. So instead of doing that, can we now refer to it from the components? Fuck, I forgot to check that out. No, borrow that. Arguments are incorrect. Okay, component attributes are not available here. That means that they are not exported. So we need to go up to here. They are public. Components are public. So that just means that this thing is all right. Where's widgets in all of this? Oh no, this is the same thing. What the shit? That is not where the attributes are. Okay, so they're in the wrong place then. Great, thanks. This is a nodes component, okay. Shit, come on, this is the wrong value. Yeah, oh. So now this is fine. Snap. Okay. All right, so we actually see code now. We could... Right. Here is a value maybe, but there is no value, obviously, because we can't see it. So let's look at the template. So we're supposed to pass in a value, unsurprisingly named value. And then in our A template, we're supposed to refer to it as attribute value, which means if we now go to widgets, expressions, where's the resolution? Come on. Do we use the second one here? Yeah, we do. All right, so let's go to the resolver. Scoping is wrong. And why is that not complaining? That is correct. So scoping is not wrong, despite what I just said. Here. Really? Okay. Is it a difference between singular and plural, maybe? Fuck. That broke it instead. But we can't see why. Because that is on. Here we go. Explicit panic on expressions 50. All right, so let's go to widgets, expression 150. Here's our explicit panic. Oh, right. All right, so this get function needs to include component attributes. And how the shit do we do that? All right, the way we do this is by figuring out what is it that it's exactly going to do with this thing, right? So we should get to here's the get function, right? We're doing an index get. We're passing in states, but we need more. We need access to the component. So we need to know where that component is actually stored so we can look up the component through the component ID. Maybe we can... Let's have a look. This is the component in question that has the attributes. Where do we store this component? This is the component widget, and where do we store this thing? In the tree. So we literally need access to the widget tree to do this. No, it's not that simple. I think we can keep going up to where we're actually doing this. Yeah, we're still resolving. So this is a singular evaluation of this, and we're trying to look this up. We need to store the attributes. No, we don't. We don't store the attributes. We need access to the attributes. How? How do we get the component as a read-only value in here? We can't store it on the context. First of all, we need the parent of this. The eval context does not contain... It contains components. But this doesn't tell us what the component is, though. We don't know the parent component. Okay. So what do we do here then? Do we track parent component IDs? All right, let's see how the evaluation context flows. We don't seem to have anything resembling parents in here, but I do think that we store something here. What is this thing for? Component context has a parent. And we're looking at an eval context, not a component context. Fudge. Okay, so what happens when we evaluate a component? We do have a parent here. No, that's the parent of the widget. That has nothing to do with the parent of the component. What is this input parent? That certainly is something. Where does the input come from? Fine. So we've already specified what that is. I guess we could translate this into the eval context where we start off with the parent ID. I did not think about this. Well, no, hang on. We kind of know what this thing is anyway, right? So when it comes to doing the evaluation, we know what it is. Yeah. Expressions 150. Here we know the widget component ID, so we can just look this up. And then here we do a state get. So we need the equivalent of this thing. Right. Let's say we get here. Probably can't get through a path, can we? No. I really need to eat something. What is quick to make that we can just chuck in the frying pan? Let me go and see what I have laying around. Give me a second. All right. Halloumi would be nice. But we're not going to have halloumi. So for this to work, we always have to use a key. There is no alternative for that. Right? This gives us an option of the, which we will unwrap for now. The fuck do you want now? That's component attributes. Oh, man. It's supposed to be an owned value as well. But is this the last thing that stands in our way now, or not? Well, that's supposed to be an option, so that could just be that. Now the value is owned by the value is owned by the thing. So that becomes a dynamic value, right? How do we know what we have? I guess we could downgrade it. Yeah, but that doesn't help. Let's just get this compiling. Okay, so we need to solve this thing, and this is not right. This is not even a little bit right. So attributes, component attributes, we're going to get hold of that so we can get values out of there. Well, that's kind of weird though, because the get function should be happening on there, right? Yeah, it's because the attribute. Oh my god. This is one of those things that I think it would be worth paying someone else to suffer through. Although, of course, it wouldn't, because they wouldn't be around to maintain it. So we have to own the pain. I guess what we could do is... yeah, all right. So we can do... Okay, we just need to get the attributes, though. So we need to pass in component attributes here. Well, that has to have the same lifetime. Yeah, we're using the BP lifetime there, so that has to have that lifetime. Oh, fuck. It's all the way there. We can't store it in scope either. Okay, 4 minutes. I'm going to go throw some food in the oven. Motherfucker, this thing sucks balls. Okay. This doesn't seem right. All this just so we can get things from the attributes. So how is that supposed to work? So we get the component attribute. And yeah, we can't do that. What a joker. What a freaking joker this is. There has to be a simplified version of this that is possible to maintain. This is just insane. This is just too much. Do we have some kind of value resolution algorithms that we can look at? Yeah, I don't think that's what we're looking for. Generate an answer from relevant content. Okay, do that then. No, that's just the Wikipedia article that we just looked at. Resolving values in programming. Where did the assistant go? Let's do this. Do what I mean. Come on, man. Maybe this the okay. We're gonna throw some things in the oven. I'll be right back. Right. We have all the values stored in two different locations, either in the value storage or in the expressions themselves, right? So maybe we could simplify this even more and make everything a really cheap storage. Oh man, this thing is annoying. Make everything a really cheap storage, right? What would that look like? We would place the values inside the value storage. That is already kind of a given. There are values that we perform operations on, that we own, and so on and so forth, right? And then we have the static values, which are coming from the blueprints. So there should really just be two places where values can live. So why is this so complicated? Is it because of how we resolve these values, how we use them, how we get access to them? Is that the problem? Because this really shouldn't be a problem as such. The same thing is true for our attributes, right? Well, no, it is. So maybe we need to take another step back. However, at this point, I feel like we've gone pretty far into the weeds with this. Ripping all this out would be rather painful. So what we're going to do is we're going to store some of this stuff. Let's have a look. Okay. All right. So I have the content of the food. Let's just do this. And then we do this. Right. I'm going to leave the stream going, but I don't expect anyone to hang out when I'm doing boring things like cooking and eating. So even though the stream will be running, I'll be sort of AFK for a couple of minutes, and I'll see you guys in a bit. All right, then. Let's see what we did leave off and what we're going to do. Do I remember this? That is a wasp nest inside an AC unit. Yes, I do remember that. Okay. I probably should have updated my stream title when I went out for food. Okay. Anyway, I need our doodling program. We don't have Asebright anymore. No. No, it's not Asebright. Let's see what it's called. Well, that's what it's called, isn't it? All right, let's build that. Alternatively, I would have to open Steam to do this. Might drop some frames during this, we'll see. Oh my god, okay. Right then. So this is going to be about values, and I think values could be simplified, but maybe not. So it should be possible to simplify this, since all values are moved into its own storage. There are no such things as values outside of the storage, so we should be able to retrieve values from the storage. This is probably going to be mostly about scoping. Yes, you can. Okay, let's see if this thing worked. No problem. Come on. Well, this wasn't fast, was it? Okay, what's this thing complaining about? Watch has not been made. No, nobody cares about that. Instead, we're going to care about other things. Okay. Okay, let's make a new one, shall we? Okay, so on one end we have our value storage. Let's just draw that out. this is where we store all our values. Nice. And then we have our expression tree. Hello, Fake Monday. What got me into programming? I was so young when I started programming. I don't exactly remember what it was about it that I thought was fun, but I kind of knew from the moment I started that programming is what I want to do and what I'm going to keep doing. Rain, maybe. Maybe it's rain I'm hearing. Who knows? Then we're going to have our expression tree, which is going to point to... We don't need this anymore. Oh, why didn't I make more tea? I did have the time. How should we represent the expression tree in all of this? Just draw down a separate layer as well. So I guess what we could do is we could draw this out as components. And then inside the components, we will have our widgets. Like that. So this will kind of be representative of our components, but still this is not quite a tree. So maybe this would be better. Whoops. For our tree. Hello Skylar, hello Wiry. How you guys doing? So these are widgets inside of our tree. And here is the set of values that we have. It's a little bit on the large side, isn't it? But it is what it is. Okay. Now, how did these all hang together? Oh, but it's not that simple either, is it? Maybe it is. Maybe it's just. Maybe it should just hang together through the scope then. Can we make the font size smaller? No, we could not. Well, this isn't quite right because we have the active widget tree. There we go. But we also have the blueprints. Thank you so much, Marvin. I really appreciate that. Thank you kindly. How you doing, Marvin? Thank you, Scott. I have to figure out how all this hangs together now. Maybe. I don't know why you have paint in your doors, Emil, but you should probably see to that. I don't remember last time I stubbed my toe, though. So here's the question. How do we tie all this together? Blueprints are evaluated into a widget tree combined with the values. I did stub my toe, so my nail turned blue, and it took a long time before the nail fell off. I feel like this is too bright. Yeah, it is too. I see. Hello, yay. Okay. How does all this hang together? The question is, do we answer that or do we make a new definition? Or then we just do that and everything turns terrible. So we will pass the blueprints into the evaluation process. So we are starting off with blueprints that becomes, they are evaluated, but they are evaluated together with values to produce the widget tree. What is it that we're passing in? So we can ask the runtime for this. We compile the document. We have not yet evaluated the blueprints at this point. Here we do that. This thing has to have a loop in it then. Yes, it does. Okay, that makes sense. This is probably the hardest thing that I have faced in this project. This will evaluate every single blueprint that we have. And what do we pass into this evaluation step? The evaluation context, which contains the scope. We can build up the scope again. That's not really a problem. So together with the states, we need this for There are too many variables here, no pun intended. So we evaluate the blueprints. This is just one of many. So how do we get to the value resolution from here? Actually, dipping into any of these will do that. This one is nice, all things considered. But it is clear that we need to know which component we're operating on. So for every new component, we could initialize a new scope. But we have to be allowed to look outside of the scope for anything that has been scoped to that. So we are allowed to follow. So here's a question that no one can answer. How much more expensive is an allocation compared to memory lookup? You can't answer that question because we don't know what memory we're looking at. So there we go. Hello, Raiders. How's it going, Ascertain? We can't answer that question because we don't know what memory we're talking about. So we can't say how much slower is this versus that, right? So I don't know that we have to simplify this. The value lookup has to be simplified. Hello, Jonatas. What are you guys up to on stream? So here we are scoping values. Maybe that's what we're doing. We're scoping to the last attribute. Hello, the last, yeah. So technically, parent is not relevant here. As the default state of the brain, though. Don't want it to be hard and smooth, but I get what you mean. How's it going? Terribly well. Sort of, but not. The terrible part is true. So we could insert into the scope some meaning here. But that doesn't help. Well, it helps us to say how far up we can go. Kind of like how we do for loop scoping. Forget control flow. Here. Are we doing any scoping here? We are. One alternative would be to store this with the state then. But we can't do that because we might already have a state stored for this thing. So that will be a catastrophe. And here we are scoping the component ID, but that's a widget component ID. Okay, then we get to the point where we store the widget components, the attributes separate from the other widgets. So that's a new storage then. If we could only have storage groups. But of course we can't. I mean, we could, but it becomes an allocation issue. We are popping the scope. That's good. In that case, we have kind of nothing to worry about. Hello, CPI turn. An insane adventure. That sounds good. I hope it's good. Does your insane adventure solve my problem somehow? I would like if it does that. So this is just going to go around. .1% overlap. I'll take it. Okay. Should we then write out the attribute storage elsewhere? And you, CP, and you. Oh my god, I'm boring myself. Okay. Okay, let's say that we can move this out into its own attribute storage, whatever that is. Yeah, the problem is why there's nothing I can do about this but solve it. It's too complicated to even describe the problem. I don't even know where to begin to describe the problem. And there's no one I can hand this over to. And even if I could, it wouldn't be ideal because then I'm not going to be able to fix it. I'm just thinking there has to be a better way to deal with this. So we're evaluating these things into a widget tree. It shouldn't be that complicated, should it? Oh yeah, here we are, right? We need the component attributes there. Yeah, the description of the problem is quite simple, right? We have to resolve values correctly within the scopes and separate the state from the attributes, the locals from the globals. But there is no way you can describe that without raising 300 more questions, right? So it doesn't quite help to know that. So according to this, we need the attribute state. And this comes from lookup, which comes from value resolution. Maybe scope test. This is clearly not the only place where we do this. There are quite a few places where we do this. This is an artifact of single widget evaluation. Okay. Every widget, every evaluation call that we make could have the accompanying scopes values, but that is mutable. Okay, let's keep looking. So this is all part of the evaluation step, and then the future step, and then the update step per chance. Oh shit. No, that's just part of this thing. This still has the eval context, so we still have the scopes available to us. Now, the problem is that we need to walk backwards up scopes. You can have values pointing to values, pointing to values all the way down. So component attributes has to be its own thing. Because we cannot use attribute storage there. I don't even know what that means in this context, Wire. Don't bother trying to explain it to me. I don't have the brain capacity to understand anything now. This is why we need expressions, isn't it? To reset the values that change. Yeah, I'm not winning here, am I? I don't even know what that means. What is a symbol table? Like, the phrase means nothing. So to create a symbol table, might as well say create a blah, 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 and put your blah, blah, blah there. All right. It holds no meaning to me. I'm not just trying to solve the problem. I want to make the solution in such a way that we don't have to have this complexity. That is literally what our scopes are doing, though. So we scope values, and they can be accessed when we resolve a value from that point on. The problem is that we have many values, and not all of them are used. So we're not going to scope every value because we're only going to get the values that we actually use. Hello, Cuberman, how you doing? Welcome, Raiders. Welcome to the most boring stream on Twitch right now. This is basically the stream. It's just me staring into nothing, trying to figure this out. Hope you had a good stream, though. Peak content, yeah. Yeah, so what do we do with this thing then, right? If we fix this from this point, then we're just pushing the problem into the future. Maybe there is no way of decomplicating this, though. That is what we're doing, Bean Juice. We will end up here again if we just write out the implementation now. It's reasonably simple. All we gotta do is store attributes for components in a separate collection, and then we refer to those. But that is hardly helpful. See, that's not something I can do, Wairu. I can't let go of a problem and go and work on something else. I would have 6,000 unfinished projects if I did that. And the problem's still gonna be there when I'm done. So whether I solve it today or tomorrow or procrastinate 2 weeks, the problem is still gonna be there. There's no getting rid of the problem, right? No, but I think people understand what you mean when you say finished, okay? I think that we don't really have to be that descriptive in our language, right? We talk about finished software. Or to rephrase it, since no software is ever finished, we can use a different definition of the word finished when it comes to software. We need better testing. Well, technically we have better testing. You just have to swap out the one that we have the scope test. Because it's not powerful enough to do the testing we need to do. So where does that put us? Maybe we can't simplify this. Maybe that's just not possible with the current model we have. I don't know. I don't know. There is no small model, right? So when you have a problem, you can usually draft this problem as a small self-contained project and work on the problem in isolation. That only works with problems that aren't composed of other systems, which is what we have now. We have the blueprints, we have the expressions, and we have the values, and we have the states. There are so many moving parts in this that trying to extrapolate this into one thing is now impossible without recreating all of these different components. Normally, there are ways to simplify things as well. You can sacrifice a little bit of something, performance or whatever, for a bit of simplification. But I think we've gone past that, so we can't do that either. Because this thing affects everything, this is literally the core of this. It has to be performant. And it has to work. So an abundance of cloning and copying, that wouldn't even solve the problem if we did, but... There are no primitives in this, Chalker. That's the problem. When you normally face a problem in the world of programming, 99 out of 100 problems can be defined in isolation. But in this case, there are so many systems that are involved in this that there is no primitives to isolate. We're past primitives. We're into larger abstractions. We're into systems that are connecting to systems, and you can't really simplify these systems anymore. I mean, you could, but that in itself would be an exhaustive exercise. Well, ChatGPT wouldn't be able to express this. The code base is too large to fit into ChatGPT anyway, so I don't think ChatGPT would have much input here. Why do you guys keep saying I'm depressed? I'm not depressed, man. I'm okay. I am pensive. I am thinking. All right, admittedly, my voice does sound a little bit depressed, maybe. I wonder if there's anything cathartic I could have done at this point. A sandbag would have been good to have. I think that would have been good. Meditating doesn't really do much for me other than it doesn't do much for solving problems. It does things creatively for me, but not problem solving. But I'm not, so that would be a lie. You could have painted. I did paint. I drew the values and the blueprints in the widget tree. It didn't help. You guys can be furries. I don't care. I don't mind. I don't kink shame. You gotta do what makes you happy. Could have fainted as well. I don't think so. And fainting is kind of dangerous, so good thing we didn't. I'm not accusing anyone of anything. All right, what activity can we do that helps to relax the brain? Okay, this is what we're going to do. We're going to take a little break from this programming, all right? Let's talk to you guys instead. Hang on. Actually, I guess we can attach this there. We'll save that one. All right, let's talk to you guys. What are you guys up to? Yeah, I put on some weight. What else do you got? What do you guys got? Can do some cold reviews if you guys have anything. We could look at anything interesting people have been working on. Anyone doing anything fun? Guys are doing rustlings. When I'm working on a video series on rustlings, I don't think John Jankset is something I watch for fun. I think he's very good at describing and explaining things, but I don't put him in the category of fun. It's not a dig at him. He's very good at what he's doing, but there's like no entertainment value in it for me. To each their own. Okay. I don't know what that means, but send us a link, Doddy. We'll have a look. Wow, you guys really latched onto the furry thing, didn't you? Let's have a look. You can watch foolish videos. All right. What are in these foolish videos then? If this is like the day in the life of or whatever, then I'm out of here. No. Okay. They seem to have a little to nothing to do with programming. Go on, share it, Wiry. Let's have a look. Probably little to no programming in there too, right? Can you only laugh about programming? Yes. Please do. I'm trying to take a break from the anathema problem, so I'm happy to look at your guys' code, right? All right, let's just grab this whole thing, shall we? Always check for build RS. Is this in a different branch? All right, that's it. Yeah. Client source routers. Yeah, seems about right. Client source routers. And you had an any there. You have documentation. That's good. Why do you have any in here? Let's find out. Okay. So technically what you could do instead is to have, you can have a type map with the values in. I want to see why we need to have different types in there. So I see all this navigate to, and then you're passing in some kind of state value like thing here. Ugh. Okay. That's part of a sender, right? Okay. Honestly, I don't see how you're going to get around having to use any types if you got to send something specific to something. So who has ownership of this then? Like, okay, what leads me to a situation where I have to send this? The type map is hidden from the user. The routers. So a router can send navigate. Feel free to link to that, Karki. So if you're on a route and you want to navigate, you communicate with that route's route. So are the routes dynamic in any way? Are the routes dynamic in such a way that, or could you associate types with them? So your history here, does this mean that I can navigate back in history and I have access to the data at that time in history? The structs are instantiated on the router. If you navigate from A to B, you still have A intact. But if I navigate from A to B to A, do I now have two copies of A? Or am I still operating on the same copy of A? That's what I'm trying to figure out, Skylar. Do we run two instances of A now, or do we do it? Okay, we go to the same A. In that case, why can't I just request the data from a root instead? Why do I send the data when I navigate? I guess that's a question. Wow, there's quite a lot going on there, Dottie. I wish I understood more what it did. Okay, so what is it? What is it about one root that needs to be communicated to another root? So I'm trying to understand where the convergence of data lives here, right? Where does, if I have a root, it should own the data, right? So I'm kind of thinking it would be better to query the root for data if you need to. Okay, so let's think about that for a second. Let's say that we have a trait called a router. And for some reason that can render. I'm not sure why, but it can. Well, you're gonna know what you're navigating to, right? So if we do this, then it's no longer type safe. But do the roots have to be dynamic? Okay, we're gonna do a quick blast through this thing. Ah, can you know all the routes up front though? Okay, let me just blast through this thing. Event registry, vec, event listener. Event listener is okay, it's a function call. Get the event. Call it with the data. Yeah, so here we store the type ID with this. Yeah. Yeah, so you know if you're asking for an event, if you don't have the right type ID, then you can't get the event or the type out, right? That's cool. So we can't really do it this way on account of us losing the we lose the possibility for object safety. So we can't store things like this because remember that a vector is in the same thing with a hash map. It's a homogeneous collection, right? We could do the trait any router. We could do this, and then we can implement like that. Now, there we go, right? So we can do this, and now we can store a bunch of any routers in there, but that still doesn't get us the data. We're going to store the key, but we're just going to be lazy and use a static stir instead. So now we have a bunch of routers in here. And then what was it that we needed to be able to do? We needed to be able to navigate from one route to another. Yeah, so we would have to have a navigate. So we could, in this event, actually, this holds its own problems because of that hash map, right? But then how do we know we're supposed to pass data, right? So we have this update of data. So here we're supposed to have data, but I don't know. Then the root might as well just be a type, right? Wouldn't it? Wouldn't that make sense? But then we can't navigate through message passing if that's essential to do, which I guess it is. Yeah, so we're receiving a navigation request here. So we do need to store the data as such. But we could also... So how do we do this without having to... If we want this to have... Actually, what we could do... Do you want to take one piece of data from one to the other, right? We just do this to be silly. So we're going to be blocking here now. Man, the number of times I press Control or Shift R is frustrating. We need to know the current route. Maybe not. Well, you know what? This is a fun distraction, so... I'm just going to see if I can swing this first. So I'm going to get the current route. We'll unwrap that because why not? Problem is that we cannot borrow from one to the other. We cannot borrow data from one route while we're having another one running, right? So this would be Am I blind? Oh my god. Oh yeah. So this is going to require mutable accesses out, but we're going to skip that just because I don't want to deal with the hash map doing that. So now we've gone to that one, and then we're going to do there. All right. We do some type erasure as we're hopping back and forth between these things, but we can, okay, let me see if we can run this thing now, right? Roots, and there's no new functional roots, so let's make one. Hashnap. It's a little bit ropey. Okay. So let's make 2 roots, right? X will be one root, Y will be another root. Let's import x, import root for x. Type data can be U32. The update function, I don't know if I, like, why did I add that? Let's get rid of that update thing. We're gonna deal with this on activate instead. We'll do the same thing for y. Ugh. Okay. Okay, so for this to work, we have to, of course, spawn a thread, right? But we'll do that here. Where we're gonna move in the TX, and we're gonna send X, and then we're gonna send Y. Now, when we navigate, we do this thing, and then we're gonna say let some, whoops, current else return, because we're not gonna have a root for X. We could have an output as well, right? For this to make sense. So we can map these together, but right now we don't. Okay, so we're not printing anything out, but nothing really happened, right? There we go. So this is supposed to return some data. Again, we can store the data on here. So U32. The first time we're gonna skip. Second time around though, we actually have something that exists, yeah? So here's our data. All right, and then... whoops. There we go, right? So now we transfer data from one to the other. However, there is no transformation, right? Let's say that the data that one router should output should go through some kind of transformation, maybe. Because you mentioned at some point you wanted just a file name, at another point you wanted some kind of collection of data or whatever it was, right? So I don't really know what we would do with that. Let's say, for instance, we wanted this thing to be a string instead. right? Now this doesn't work anymore because we're converting from one to the other. So I guess what we could do is when we are sending a message, we could also, to make things more complicated, we could send a transformer along with it. So now we're really gonna get in the weeds of things, right? And this is just because it's fun, right? Well, you can kind of see where I'm going with this because we're not really doing anything different here. Right? We're just putting a different coat of paint on this thing, right? So now we're going to import T transformer, any transformer for T. So we're going to get our first input here and our output. So the first thing we need to do is say that input. No, that's fair enough. That's fair enough. That I can understand. Input dot downcast ref to T input. And then we're gonna do the transform. Right. Transformer. We'll unwrap because that's how we roll. That's gonna be... that's incorrect. That's input and transform should get... Oh, sorry. A reference to that. And then we can return a box dyn any instead. It's not loving that, but let's just do this for now. So this will give us the output. So we do a box new output. Okay, so these all have to have the same static lifetime. There we go. So now we have the notion of a transformer. So we could implement a transformer that we send along when we send a message, right? So we register our roots, and then here our send, whoopsie doodles. We're gonna send the root name, and we're gonna send X to... No, we're going to send Y. Let's send nothing here. A unit, if you will. Then here, we're going to send an X to Y. And then here, we're going to send a Y to X. Right? So we send it. We need two different transformers for this, right? What do you mean no? Fix it. Fix it. Fix it. All right, I can't spell again. All right, so the input, so going from X to Y, the input is the input of Y. So that's going to be a Y data. And the output is going to be an X data. All right. Oui. All right, and then we're going to do the same thing here. And then the actual transformation. So X data is going to be a reference to... We should be able to see what type this is because we specify that there. Okay, let's just do this. Like that, right? I am not. Hello, scientists. How are you going? Welcome back. All right, so we would have some. Where was I now? Shit, and I lost my train of thought. Thank you so much, Uncle Scientist. Thank you so much. I really appreciate that. Thank you. Right, so where's our TX? RX. There we go, all right. So we'll do that. And we'll just take a box down and a transformer for this thing. Right. Okay, so now we can, when we get this thing, we're going to have a key and transformer. Right. Now, this thing doesn't implement. So I guess what we could do is we could start off with X so we don't have to implement an empty one, right? So we don't have to implement. We're just going to go from X to Y to start with. So we'll start this off at X, right? It's not that much of a problem. It just means that we would have to... Oh, can't do that. Okay. So what we're saying then is that we can implement transformer for something if we disregard the values. So we can have a unit being a transformer of any to any and doesn't really do anything. It becomes like a no-op. But rather than having to implement that, we just throw something in there for fun now, right? So here we're going to do the transformation. So now we should actually know what type this is. It's a reference to a string. And what are we actually expecting, right? We're expecting... Actually, the input is... We're going to go from X to Y. So the input should be the X data and the output should be the Y data. There we go, right? So now we're getting a U32 and we're supposed to return a string. So we're just going to do input to string, right? And that's our transformer now. So now we can transform from one value to another value, right? If we wanted to, we can now invert this thing as well. A Y to an X and then Y there, X there. Change that to a Y, change that to an X. So now our input will be a string and we have to parse this string. So we'll do input dot parse to self output and unwrap or 0, right? Because we have to have something in there, right? So these are now two different values. What we can put in here is just a string new. So we're going to translate that from one to the other and then back again, right? So we have to box this thing up again. And then back to Y again, right? So we are, okay, so we're ending, whoops. We're ending up with an unwrap on none here for 60, which is the activate. Yeah, so we haven't actually done the transformation yet, right? So jump the gun there a little bit because we're passing an incorrect value into this guy. So when we navigate, we have to apply the transformer. So we're going to get the current data, and then we're going to have our output or our new input. Transformer dot transform the data. Now, how the shit does this work? This will then transform the data for us. We're going to get the root, and then we're going to pass in activate, which should take a reference to our input. All right. Okay. So we're almost there. I probably just got my wires crossed somewhere. So let's go to 60 and let's put a breakpoint there. We don't really know what the input is here, right? It's just going to be, right? So we can go up from here. So we're supposed to pass in the data to a new root, and this would be Y. This thing has successfully been transformed. And then we're going to get the new root, which is Y. And the transformer should be an X to Y. It is an X to Y, which means we should be getting the input of X and the output of Y. Right? So this is our input. And we're returning the output. That's the output, which is now a U32, yeah? We're going to box up that U32, get the new root, and to activate this thing, we're supposed to downcast this, but it's not downcasting correctly. Is it because it's boxed? That might be why. I'm gonna assume we can't do that. We could do that. We just get rid of the box, okay? Just get rid of the box, don't worry about it. Okay. All right. But there you have it, right? So we can go from, oh, look at that. That one has failed. That one has failed. We can probably get that working, but the essence is there. We can register these transformers to go from one route to another route, and we can translate between the data between these two different routes as well, right? Should we find out why that thing was knackered? So when it comes to activating for this transformer here, what is this input? It's an empty string. So this input here is what? It's an empty string. Oh, right. Because, of course, we made it into an empty string. Instead of... I never made it mutable. So that's on me, right? Let's make this into a number. And we're good. All right. Thank you, Wairu. It was quite relaxing for me to do this instead of actually tackling the read problem I'm supposed to be tackling. It is incredibly powerful how you can design with Rust and do dynamic things as well as not. We're making use of something called type erasure for this. And so what we end up with is we have two different routes, and we're describing how to transform from one route to another. This means that if you don't have such a transformation layer, you couldn't go from one route to another, right? Let's say that we made another route called Z, right? That holds nothing. Like so. We wouldn't be able to we wouldn't be able to navigate to this route because we have no transformation, right? Yeah, but you get there though, Ari. I think you seem to have done pretty well for having done Rust for only 8 months in that case. So we kind of need something that allows us to no-op the transformations, right? Maybe we make the transformation optional. Maybe we make an actual no-op transformation that will do nothing and we just pass the value through. What button was that? Okay, I don't know, right? But yeah, so we can register set, right? No, we can register set. But we can't navigate to it because we have no way of translating from one to the other, right? But alternatively, we could make a navigation translation that doesn't require us to output the old data, right? But yeah, I don't know. I guess that pretty much covers it. The adding the layer of indirection makes it easier in the same sense that it's difficult to try to pile all your code into the main function of your program. So it's not like indirections or indeed abstractions are bad, right? They don't make the code worse. They make the code easier. As long as you understand what it is that we're doing, then it makes it a lot easier to reason about, right? Goodness, Cretaceous me. Now what do we do? Are we going back to our pane that we had before? Well, let me know if you get stuck with this stuff in one way or another, right? I don't know. Oh, you know what? I'm being a big dummy. Don't tell anyone. There we go. I'm good. I'm good. But these are architectural challenges that are interesting in Rust. What would be another way that we could do something like this? Cargo, new stuff. Without reproducing anathema's value structure, because no one wants that. I wonder if we could express this without something like this without without using dynamic anything. The value system in anathema, the foundation of it is quite simple. You represent the value that is strongly typed, but you don't actually keep the value itself. The value itself is moved into another storage and the type is lost. It's only by trying to access the value again that we're going to pull it out and then cast it and then get access to it. So for all intents and purposes, we're working with a strong type system, but the values are entirely dynamic. So we could, the only way we could do this that I can see is if we were to pass. No, we would have to build the root structure up front, and then it wouldn't make sense anymore. No, so we can't do that. You could build the transformers as a static. No, you couldn't. I was thinking we could do this with value chaining, but that's not super exciting to go into. Like, because I'm thinking like what you could do is if you have something like a trait transform where we have an input, sorry, type input and output. Now, what we could do is we could have a struct called a chain, and that's generic over A and B, not A and B. And then we would have a function called chain here that takes ownership of self and another, where T is a transform where the input is self output, right? Hopefully that makes sense, okay? And then here we would return, sorry, I don't have time now. We would return a chain of self and T. And all we have to do is create a chain here where A is self and B is other. And there we go, right? I haven't written transform correctly again, have I? All right, hang on. This might be important. All right. Can't find trait output in self. No, so right. Sorry, I got a little bit confused where self is sized. Right, like that. So now we can actually chain multiple transformers, right? Even if we only have, like what would be a good example? Okay, we can make some silly transformers for this thing to make sense, right? So let's start off with byte to string maybe, and then we can have a string to byte. And let's implement the transform trait for byte to string. I cannot write the word transform for some reason. I cannot. So the input should be a byte and the output should be a string. And then of course we need the actual transform function with input that is, we go with references. Actually, let's go with own values. Input, and the output is, or the return value is self output, like so. So we need to do the transform implementation for chain. So we're going to import transform for chain. A and B, and then here we're going to say where A implements transform and B implements transform where the input of B is the output of A, right? Hopefully this makes perfect sense, right? Okay, that's going to be A input, and that's gonna be B output, or put if you can't type, right? And then here we're gonna do self.a.transform input, and we're gonna return self.b.transform that, right? So the input of B is the output of A, right? And then we're gonna do the transformation here. So our input's gonna be a byte and our output's gonna be a string. So we're gonna do input.toString or string if you can't write. Okay, so that's our byte to string. To do our string to byte will be almost the same, right? So we're gonna swap this for that. And then here we're just gonna do input as bytes dot first dot unwrap. Right. Kind of a gross thing to do, but I guess we could do copied here to go even more gross. Okay, no, it is not an iterator. Well, hello dref. Okay, so now we have a string to byte and a byte to string, and we can now do something like a struct bool to byte, for instance, if we wanted to do that. And we can implement the following nonsense for this guy. Bool to byte, so the input is going to be a bool, and the output is a byte, and the input, so we're gonna say mention input, or maybe we could just do input as u8, right? Whoops. To be even simpler, right? So now we could theoretically go from bool to string by saying bool to byte, and we're going to chain this with, so the input of the next thing is going to be the byte byte to string, right? And then we can go from that to string to byte, yeah? And then back to, I don't know, right? So this is going to be our transform now, which is entirely compile time assembled. So if I'm going to call transform, let's call this transformer, right? The transform, and now we should be able to leverage the type system. And back to bool again, but then we need a byte to bool. But we could have had a byte. We can have a byte to bool if we wanted to. Although it's not really going to work, because when we do the conversion here, something odd's going to happen. But when we transform here, we can see the type that is missing a bool. Okay, then we say true. And what's the output? Well, we can just ask, right? It's a byte. There we go, right? It's 49. I don't even know why it's 49, but it's 49, okay? So now we've gone through, so we can chain these as much as we want to, right? So we can go back to, we got string to byte. We can chain this with a byte to string, and all of a sudden we have a string value, right? 42 would be magical. It's a little bit weird that we're casting a bool as a U8, and that means that the input of B transform. Actually, let me run this again. Step through this. So now our input is 1, and we're going to call 1 to string, which obviously translates to 49. That kind of makes sense. So why don't we do this thing, right? Why don't we say that we have input, and then we're gonna add 10 to this thing instead, right? 59, 20. That should get us into character territory, right? So when we do our string to byte, we're gonna do our we're gonna do a struct byte, whoops, byte to car, right? And we're gonna transform, and input's gonna be a byte, and the output's gonna be a car, right? Now we also need to go from a car to a string, right? So we need one more, right? We're gonna have a, whoops. Like that. Thank you for the follow. And then our input's gonna be a car, and then we're just gonna do a simple format. Actually, we can just do input.toString here. All right. So let's take our chain. So we're gonna go byte to string, and then we're gonna go. We're gonna change this to byte to car, and then chain this to car to string, right? There we go. What a beautiful chain. Oopsie doodles. Oh, chat to string. There we go, right? And there's our number 2. I don't know why it's our number 2 now. Hello, Yogurt. I've completely lost track. So we're gonna convert this to 1. Then we're gonna do byte to string. At which point we're adding 20 to the byte. So yeah, that doesn't make any sense. That's just gonna make it into a number, right? Which instead do like bool to byte, which is 1, and then byte to string that converts into an actual byte. String to byte. Really, this is what we should do, right? Plus 20, something like that instead, right? Now we get an F. Okay. Now we get an F. Because we convert this into something. I mean, why would we do this conversion here, though, right? We have a string to byte. Why don't we have another one called a byte offset, right? So we do byte offset that takes an actual offset in there. It's going to take an input that is a byte and an output that is a byte, and it's just going to do input plus self.0. So instead of us doing this here with our byte to string, before we do our byte to string, we're just going to do a byte offset of 20. Well, but let's just make this into a byte, right? Doesn't really matter if it is a byte or... whoops. What? Ended up in the wrong place. There we go. Now, hang on. Why is it 2? So bool to byte and then byte offset. That's gonna add 20 to this thing. And then we're gonna do a byte to car. So that's gonna take an input and then we're gonna do car to string. And we got nothing. It's after string to byte. So we do bool. Oh yeah, no, we have to. You're right. So we have to do string to byte first, right? No, we have to do byte to string. There it is. Okay. So now we have like our offset, but you can sort of see how powerful the program can become, right? Sure, there's a lot of text here, right? There's a lot of code here, and ideally we don't have to look at that much code. But if you look at the program itself, you can kind of follow rather contrived and ridiculous transformations that we're actually doing, though. But you can follow the transformation as we go, right? We are basically just building up all these things at compile time, right? If you wanted to, you could make this dynamic. You could imagine this as part of a game if you wanted to, where you have where you go back to what we had before with the transformers, and you can have you can build up a collection of attack modifiers on a character by just keep adding these things, right? Now here we're doing it at compile time, but you could very well do it at runtime if these were dynamic, right? If we did what we did before, right? Are you unchained? Are you unhinged? How are we doing with this thing? Okay, cool beans. Then we can transform with the transformer to get the output. What else can I show you then that's fun to do while we're at it? All right. What we could do, I can show a simplistic version of anathema's value types. Because this adds a little bit of magic to it, all right? Now, the first thing we're gonna do is define what a value is, all right? We're gonna say that this is generic over t, but we're not actually gonna store the value here, right? If we did this, we're done, right? And then we're gonna import dref for value t, right? And this is something that we're not gonna be able to do, right? And whoops, self.inner. So if we did it this way, we could now create a value. Let value equals value new 1, 2, 3, or yeah, why not 1, 2, 3, right? Let's put an import block here. So we are definitely going to have to make this static, right? Okay, and since we can dereference this thing, we can technically treat this value as a reference to 1, 2, 3, right? We can do this by just printing out the value. We cannot do this by just printing out the value. We can do this. All right, so there's our 1, 2, 3. So println will not alter the ref apparently. But this gives us somewhat of a predicament. Let's say that we want to make this mutable, and we were to add dref mute to this as well, because why wouldn't we? And then we're going to have dref mute here. We don't have target because that's already implied by dref. We're just going to change everything to be mutable. Yep. That's a noise you have to make in program Rust. Okay, so now if we wanted to, we could do value plus equals 1. If I try to compile this, this will fail until I dereference this thing. And when we run it, it now says 1, 2, 4 instead of 1, 2, 3, right? Okay, so we can do this. And of course, what if we now wanted to have 2 mutable references to the value? Now, of course, you can't do that because Rust will not let us. But what we could do is we could sort of cheat, okay? So we're going to get rid of dref and dref mute from this thing, and we're going to have a function called dref here. Dref mute takes a mutable reference to self, but what if it didn't take a mutable reference to self, and it gave us a mutable reference to t? Actually, it's not going to give us a mutable reference to t. It's going to give us a mute ref t instead. And we're going to do some magic in here. And then we're going to have our struct called mute ref. That is going to be having ownership of t. And this is where we're going to add our dref mute now. So let's import. I kind of wish I would have said that now. Okay, let's import dref for mute ref t, and we're going to have dref mute as well. Target is t, and that's just going to be self.0. Okay, So if we now had this, okay, we could do this, right? Let v1 equals to value dot to mute, and now we can do v1 here, and this is now fine. I mean, it is if we actually were to write properly. Well, that has to be mutable if we could do that. Okay, so this will compile, but we can also do this. And that's a little bit crazy, because if this were allowed to run as is, we would be in a lot of trouble, right? Because we're trying to use the value here. Okay, so that simply cannot work, right? Instead of doing a to mute, we can have a reference to this value instead. Well, okay, let me do the implementation of this now, right? So thread local. So what we're gonna do is we're not actually gonna store the value here, right? We're not gonna store the value on this thing. Instead, we're gonna use something called a marker phantom data. And we're gonna say that this thing just knows about this type. That's all it does, right? And we're gonna do, we could just do this if we wanted to. But if we want to make sure, since we're storing this in a thread local storage, we want to make sure that no one else can send this to another thread or do something untowards with it. So what we do is we do this, right? And just by the fact that we have a pointer means that this value cannot transfer this value cannot move between threads. That's all this is doing. We're not going to do anything weird by having pointers or anything like that. The only reason we have this is to prevent this thing from moving across thread boundaries. That's all we're doing. So as magical as this thing might look like, this is just a type that's saying that we are constraining the type to something. The moment we do this, if we don't have that there, we have the type parameter t is never used. Rust is not going to compile this thing, right? So we do this, right? We do this instead. And then this just becomes phantom data. And all is well. I mean, except that this thing doesn't work. This thing's just going to panic, right? So what we could do is we can now store all our values here, right? We can have a static. Let's use a ref cell that lives in cell. All right, static values is a ref cell of box dyn any. Okay. All right, and we bring our favorite any type back in again. Okay. All right, there's supposed to be a vec, sorry. A vec of box dyn any. So what this means is that we can store different types in there. All right. And instead of storing just a box dyn any, we store an option. Box dyn any. Okay. So we can take values out of there when we use them. So in our to mute, now we're going to do something, right? We're going to take values, borrow mute, and then we're going to operate on values in here. Actually, we do want the old panic here. We're going to have a value here be equal to... What should we do here? None. Like this. And then... Actually, probably not that. Oh yeah, so when we create one of these things, we now have to insert the value. So the first thing we're going to do here is we're going to get ourselves an index. Now, I think that this thing returns... with borrow mute. Shouldn't that be a slab? Yes, but we're not going to introduce any complexity here, right? We're not going to introduce complex types. If you guys want to know about slabs, you have to go and watch the video, right? I am just showing the basics of this thing, right? Okay, so this thing's going to complain because we haven't given it a type. We're just going to do that for it to shut up, really, right? So we're going to make sure that this thing can actually return something. So value.get1, or rather value.get. Let's not even bother with getting, right? Oh no, here we go. That should probably be plural. That's going to be a length. And then we're going to do values.push, the inner value, and we're going to return the index. And I don't know if this thing is going to allow us to do this. Box, new, inner. Whoops. And we got to remember that this is an option as well, right? Whoops. So that's sum, right? We're adding quite a lot of complexity to this thing, right? Of course, this thing has to have a static lifetime if we're going to be able to do this thing, right? The same thing is... Well, hang on. We're not ready for that yet, right? Okay, so there we go. Now we have an actual index. Well, apparently we don't have an index. So we want the index to be stored here. So this is really just a pointer to where the data is, right? No, you don't really, given that we're using options for that here, though, right? And okay, right. So we have the all right. So we store the index. So our value is really just a numerical representation of or rather, it's an index into this thing, right? You can think of it as a very crude pointer, if you will, right? If you squint hard enough, this is a very crude pointer, right? So right. So when we're gonna do the push on this thing, and we're gonna insert the value there. So to get the value out of here, right, we have to do value, plural again, values. We're going to index using our self.index. So that's going to get us to the value. And then I'm going to do a take here. I'm going to unwrap that. All right. So this is going to give us the actual value that we're interested in. Okay. That should now be a T. So we can now return a mute ref, which is wrapping the value. Okay. Oh, right. I jumped the gun a little bit, right? Then we have to downcast this thing, right? Because this is a box, we can do a straight up downcast. If this was a box, if this was a dine any, a reference to dine any, then we can either only downcast mute or downcast ref. But since we have a box, we have a downcast that exists on the box because the box is wrapping an any. So, all right, I was a little bit surprised there why that wasn't working. But if we look at the downcast here, we can see that this thing is implemented for anything that implements for box dine any, right? So this specific type, there is for the allocate, don't worry about it. So we should now be able to downcast this thing, and we can unwrap here, right? Because we know, we can expect here that this will, the type is associated with the value, right? Like so. Okay, so what are you angry about? That's not a, that should be T. But it found a box, even when we downcast. Okay, well, let's just dereference the downcast value then, and right? There we go. So now we can take the value out, and if we were to do this twice, if we were to call toMute twice with this value, then it would obviously fail, right? So we have to put the value back when we drop this. So we can implement drop for mute ref t. And this thing's going to require the static trait bound. It just says that we cannot have references on this thing that doesn't belong or that are anything but mutable, right? Okay, there we go. Hello, Don, how are you going? So we need to store the index on here as well, right? So we're going to do self.index. So our mute ref needs to store t and the index. Like so. All good, mate. All good. I'm distracting myself from my problem by creating new problems elsewhere. And when we drop this thing, we can now put this value back, right? So we're gonna do but we have a bit of a problem because this thing has ownership of t and we can't really move that out, right? So what we really need to do is we need to get to the value, and instead of taking, we're going to replace with self.t here. And this is going to be self.1. But we can't really do this. Actually, this has to be a box new. We have to box this up again, right? But we cannot move out of self. So instead, what we can do is we can just put an option here around this thing. Okay, so far so good. So we're going to grab our value here. Wrap that in sum. This means that when we dereference this thing, we have to do self.0.asRef unwrap. And then here we're going to do self.0.asMute unwrap. Okay. And this thing should then take and unwrap. Right. So now we can get values out of there and back in again. So let's just look at this thing. We're going to drop V1 here. And then we can print out V2 maybe. There we go. 125. So we've added the value twice, right? Whoops. Where did you go? So at no point did we ever really... at no point did we actually have... access to or like ownership of the value. But here's the funny thing, right? Let's say that we have a struct called our container, right? And this thing's gonna have a value, which will be a value over U32, right? So what we could do with our value is we could technically implement copy on this thing, right? So we can copy these values if we wanted to, right? So we can have our container, our C1 equals to container, where the value is going to be our value, right? And that would just compile. This will compile and run now. So we still have our container with the value, okay? And the container can mutate the value if we wanted to, right? It says impl container. So value.toMute plus equals to 100. Sorry, self.value, right? So once we create this container, we do all this thing. We can say C1 dot change here, right? If we make this thing mutable, right? 225. That's pretty spectacular, all things considered, right? Because what we're actually doing is we create the value, then we move the value into the container, right? And the value doesn't have to be a number. The value could very well be a string, right? It doesn't matter. Then we're going to grab a mutable reference to the value, even though the container still has access to the mutable value, right? So the container has access to the value, and we have access to the value through V1, if we wanted to here. We cannot do this while we hold on to V1 though. We can't actually have mutable access to the same thing over and over, right? So it's an RC ref cell that can be copied. Kind of a bit like that. But the storage is uniform, right? It's up here, which means that technically we can create weak references to this thing, right? Which you cannot, well, I mean, you can, I said weak references. You cannot create read-only references, right? But we can very easily do a read-only reference through here. And this is very important. So if we grab this code here and we just call this ref instead, And there we go. We're going to replace this thing. Deref, blah, blah, blah. There we go. So now we can have immutable references to this thing if we wanted to, right? Now, if we were to sort of follow suit with what we do with anathema, then we would actually do a lot of that, right? No, this implementation does not leak memory. Like, if we ran this with valgrind, there would be no memory leaks. As a matter of fact, why don't we just do a valgrind cargo build? And then we do a valgrind with target debug values. All right, and there will be no leaked memories. All right. No leaks are possible. When do you remove the value from storage? Well, that's when thread locals goes out of scope, right? Which is when the thread goes out of scope. But in our case, we just do everything on the main thread. Thread local memory cleanup can be, you can read about it in here, right? I thought the memory was mentioned here. I thought the alloc was mentioned in local key. Apparently not. Really? Very well then. Anywho. Okay, so yes, there are no memory leaks doing this thing, right? And if we wanted to, we can now have our own values here, and then we could, if we want to, have borrows here, where we store an RC of Boxstein any, right? Now, this becomes more complicated because this one involves us then checking for the last RC used before we move it back into values. We're not going to do that implementation now, but doing it this way, we could theoretically have multiple references to this thing, right? And that's how anathema actually works with values under the hood. When you borrow a value mutably, you have exclusive access to it, and you cannot have multiple mutable borrows, right? But what you can do is you can have multiple immutable borrows. At that point, we move over to RC. To show this briefly, what we actually end up with is our shared borrows, and shared contains an RC slab, which is reusable RC. So we don't keep allocating these things, right? It checks out the values on the slab, right? Yes, it does, right? It checks out the values that we have here, and it does the same thing for anathema. If you have mutable access, you have a unique owned instance of it, but these values don't exist in any place where they're used until they are being used, right? Which is an advantage because so that's kind of how RC works as well, except with RC, you're incrementing a counter, right? Here, we're doing a little bit more bookkeeping, but this allows us to have immutable access to something and also have owned access to it, right? This is something you cannot do with RC. With RC, you end up with something called an RC ref cell. And an RC ref cell, you're always going to end up cloning the RC. And if you clone the RC, you get the ref cell. If you get the ref cell, you have access to it mutably, right? So we don't want that. We want either shared access where we can just spread these values out as we see fit, or mutable access, which is where we modify this thing. This is also what's responsible for creating the subscribers and what have you, right? All right, okay. Maybe I'm losing everyone's attention span on this stuff now. We can move on to something else, right? I can show you one more thing that is pretty useful when it comes to this stuff. And that would be a collection which there are a couple of different ways we can do things, right? I like that you refer to it as a golden fish though, right? Okay, so what we have when we create a vector of values, we end up with something like that, right? So now we have access to the values in this vector, okay? But one of the things that we can't do is we cannot have a mutable reference to 1 by doing this. And a mutable reference to 2 by doing this. Now, Rust will actually let this compile and be super cool about it until we actually try to do something, right? If we try to do this, we're now in trouble, right? So we can't really do this. But what we could do, not even a little bit, Temporis, not even a little bit, right? Actually, I wonder if I'm going to show this. This is not super interesting, and I'm kind of boring myself a little bit with this stuff. I think we're going to move on from this thing, right? I was going to show you how we can actually achieve this, but I think I'm a bit too bored by these things. It's a useful pattern, but the long and short of it is we would do something like this. V dot with and then we give it an index, and then we have the value there. And then we would have more values associated with this thing, right? So we could do this in a nested fashion. I mean, maybe you guys can see this and figure this out, right? So that would be 1, that would be 2. Well, it wouldn't look like that, right? It would look like this. And then this would then compile. Oops. There we go. So now you should complain that this with thing doesn't exist. Right? But if you wanted to, you could of course implement this thing. You can probably see how this works, right? We would take a mutable reference, or we wouldn't take a mutable reference, but we would do something called checkout, right? We would check out the value at 0 and leave a placeholder in there. And when we're out of scope here, this thing, this would put 0 back, and the same thing for 1. So this would work. This would panic on account of the value already being in use, but it wouldn't be a compile time error, it would be a runtime error. And again, this would be entirely safe code. So this is also fine to do. But do we want to implement this? How often do you actually need to do this? I don't know. How do I call this pattern? I don't know if there's a name for it. I call it a checkout list. So I would have something like an entry enum, which holds a T, which is either checked out or occupied, right? T. So when we get the value, we're gonna have a struct called a value T that also contains the index of a usize and the value T. So when we drop this value, or when we're done with this thing, we can just insert this thing back at the index instead, right? Okay, maybe, all right, let me briefly implement this thing then so we can actually see this. So hopefully it will answer the questions, right? So every value we store in here is going to be an entry. So let's do an impl of our collection here. And let's make a new one, inner vec blah, right? Simple enough. And then we're going to have our push. So why don't we just do collection new and then v.push. We're going to push 0 and we're going to push 1. There we go. So we have the values. Push takes a mutable reference to self. And and a value of t. And here we'll do self.inner.push, and we're going to push an entry that is occupied that contains the value, and that's how we get the value in there. Then we're going to have the function called with, which takes a mutable reference to self. And this is now going to okay, so what do? We need index, use size, and we also need a function to operate on where f is an fn mute that takes a mutable reference to the value and also a mutable reference to self, right? Which is how this works. So we don't actually return anything. And then that is generic over f. And now we're almost there, right? This thing, there we go, right? So now this compiles. So you can kind of see how this works, right? The first thing we're going to do is we're going to take the value from self.inner. So we'll do self. We're going to have the ticket, call it ticket. That's going to be an entry checked out. We're going to make this mutable, and then we're going to get a value. So we do self.inner, and then we're going to do the index, and we're going to take a mutable reference that, and we're going to do a mem swap here, right? So we're going to swap out what we have there for the ticket, okay? So this thing, we can now match on the ticket or the tocket. And if this thing already checked out, then we're going to panic, okay? Value already checked out, right? Yeah, right. If it's occupied, then we actually have the value, and here we can do something with the value. So we can do self dot, no, we're going to do f with the value. Although the value is owned at this point, so we pass a mutable reference into it and self as well. All right. So far, so good. So far, so good. And once we're done with this function, we now have to put this back again. So we're going to swap inner for ticket again, right? Yeah, we moved that, didn't we? So let's do that then. There we go, right? So then we put it back. So technically we never needed a value in the first place. And then once we're done with this thing, we can now, let's make an iter on this thing as well, right? That is going to take a reference to self, and it's going to return impl iter, where the item is a reference to t, and we do self.inner.filter map. No, yes, maybe val, match on the val. Or not. Oh, iter. There we go, right? And if this thing is occupied, we're going to return some val. And for any checked out value, we're just going to return none, right? Okay, so this is fairly simple. If you can spell iterator. So now we can say for val in v.iter, and we can just print out the val. Whoops. And we can now see that all the values have changed, right? Let's add 100 to each so you can really see, or 200 to this guy. So you can see the values have changed. You could use an option if you wanted to, but I think this one is a little bit more specific as to what is happening.
if you use options for everything, then you are not gonna really remember what is going on when you look back at it some years from now, right? But I feel like telling some of you that is a little bit like teaching old people to suck eggs, right? You guys know how to do that. But anyway, this is a very useful pattern because it gives us access to the collection at the same time, so we can have two mutable values from the same collection. There is one more way you could achieve this if we were to do this with a standard vector, if you wanted to, right? So this involves moving the values in and out of the vector, right? But what we could do is we can create an actual vector here with the values 1, 2 here, and we can do this, right? We can do v.split at 0. I think that's how we would end up with this thing, right? So if we print out what is at A, let's not bother with that for now. Okay, so split at 1 then. All right, so there we have 1 and 2. I don't know if there's a split at mute. There is. Okay, so now what we could do is we could take this code here and we run this thing. This is our 1, 2. So we can say here that A 0 plus equals 100. Actually, that's also 0. That's going to be B 0 is we're adding 200 to this thing, and there's our 101, 201, right? So we now end up with two mutable references to the same thing. But this thing, you could probably encode this so you could do something similar to what we're doing, right? But this thing becomes more and more convoluted the deeper you go, right? So we're going to have B and... Sorry, yeah, B and C here. Then we have to do B.split at, right? Right? But you can sort of, you can see that we can only do this like 2 at a time, right? And we keep splitting these things, right? I think I don't think I have anything else to show that's of any interest around this stuff. This is pretty pedestrian and mundane things, but this is useful when it comes to things like having to manipulate values in the same collection. In our case, we do this a lot with the widget tree. This is how we can have values from the widget tree available and change while we change other parts of the widget tree, right? We have access to the widget tree when we're manipulating a component, which lets us do things like, okay, get all the children of this component. Because the values are stored in a flat list. They're stored next to the tree structure, right? So we need to be able to get the value, access to multiple mutable values at the same time. Thank you so much, Temporis. I really appreciate that. Thank you so much, buddy. That's very kind of you. Thank you. All right. Is there anything else that we can talk about now? I think we're going to do away with the collection stuff now because that's boring. And all this is boring stuff too. Oh, damn it. Then it's just this thing left. But I guess what we could do is just implement a separate attribute storage for the components, right? That's what I was thinking. Oh no, we're back. Yeah, I'm sorry, we're back. I don't know what to do, right? So that, but we can talk a little bit about Rust in general, though, right? What we have is we have a vector, and a vector in Rust is a really good. This thing is really good for building more complex types, right? Sorry, I'm trying to read chat and I thought you were already clued up on the Hindley-Milner stuff, right? You got this. You got this. Yeah, so a vector, right? A vector is it's really simple. You can push values to a vector, you can remove values from a vector, you can insert values, and you can iterate over the values, and that's it, right? But a vector can be a foundation for a lot of really cool data types, right? There's a lot you can do. Now, technically, you could create a linked list out of a vector, although that kind of defeats the purpose a little bit, I guess. But there's a lot of things that you can build from a vector. You can build tree structures and all these things. And there are added benefits to having the data in contiguous memory because it gives you fast access to it, right? What should we do? I don't really know what we're going to talk about now. You guys are going into talking about AI and you've lost my interest. So I don't know what we should do next. Maybe we just bail. Or we try to implement the attribute storage and move on. That kind of has to be done. So I don't know. Talking about editors, that's almost as interesting. So thank you. Attribute lookup can go over a new type that's access to state as well. To get the component attributes into this, there could be separate storage for component attribute. So I don't know exactly when I wrote this, but it was many hours ago. But I think this might still stand. If anything, that might be something, right? You don't look too enthusiastic for it. No, I'm not. Right? This problem is pretty big and soul crushing because it's such a big change, and I know that the change is going to bring in new bugs that we've kind of already solved, but we don't have much of a choice but to rewrite this stuff. Rewriting it is going to introduce the same old bugs that I vaguely remember how to solve. And more importantly, there is no way to reduce complexity, right? I asked chat questions about this. Questions about what? All right, let me bring chat back up again. So what is it that I'm asking chat questions about? I can obviously not ask chat questions about the problem I'm facing here because it's way too ingrained into this thing, right? There's maybe like 4 or 5 people in the chat who would be able to talk about this, right? But specifically the context around this is too big, right? There is no way anyone's going to be able to have a meaningful conversation about this bar the few people who actually know about this, right? 4 to 5 people is enough. All right. Who here in chat feels up to date with expressions RS and the problem we're trying to solve and feel like they can have some input on this thing? Okay, there's one person who knows about expression RS, but don't know the approach is like. The thing is, I don't think it works, right? So the problem domain is too vast. The issue is that this is something that is composed of multiple complex systems. There is no way to reduce this into something simple. I don't know how you would. Like some content at least. Yeah. Yeah, but so this thing touches on the values. It touches on scoping. It touches on expression evaluation. It touches on templating. There's so many things that's involved in this, and I don't even know how we could simplify this. I literally don't know how we can simplify this. So I did some basic simplification of this in here, all right? But we still have, so we're taking globals out of the equation for now. This is about as simple as we can get, right? But doing something like calling get on this thing suddenly requires so much more information. Getting values and so scoping. Yeah, scoping is one of the issues. It's not a feature. Well, that's not true. There is a feature attached to it. By prefixing state as part of our template variables, it means that we can add more things as state. Right now, we can only have named structs as state, structs with named fields. If we can prefix it with the word state, that means that you can have a number as your state, which just makes sense, right? It would be great if you could. You can have enums as state. You can have enums as part of your state, even if you use named fields, right? So all of this is required to be able to have tuple structs, enums, or simply unnamed state values, because we can refer to them as state to get access to them. But to do that, we kind of need to do this. But I did something half foolish in doing this. I also collapsed the attributes on the components so that they become what was external state. And yeah, it just means that we need to store attributes separate for components as we do to other widgets, because we need access to these attributes as well as, so this thing can be seen. Yeah, we don't have component attributes available here. If we don't have component attributes, then we cannot look up. We can't do an attributes get there, right? Yeah, so panic to move on. If we go to the runtime, there is a situation here somewhere, probably in the tree. Here, we need mutable access to the components attributes, and we also need access to the attributes here. So here it is reasonably simple, because we can just pass a reference to the attributes into the component context, but we cannot pass a reference to the component attributes into the evaluation context, which is what we need when we're going to go and evaluate new widgets because of changes to state or the initial evaluation of the tree, right? It is, in other words, a horrible pain. It's lemons in the eye. That's what it is. And if we just move the attributes into its own storage as a possibility, we could maybe do this with a sparse index, which would mean double lookups. Let's see if there's like a sparse Rust sparse index registries. Yeah, no, that's the sparse index. Okay, damn it. Maybe like a sparse index map would be better. Hello, Mark. How you going? Suffering, yeah. Maybe. No. Emotional support chat. A sparse secondary. That seems like something relevant to us. Sparse secondary map. If this thing contains, wait, where did you go? Okay, so this one is just a hash map. Huh. That's the one. So they're doing this with just a hash map. Oh, I see what they're doing. So they're probably just storing. If we look at a slot, it probably contains. No, that holds the actual value. I would have thought maybe that points to a further index, but it doesn't. So how is this sparse then? I guess it's sparse, unlike a secondary map. If they have a secondary map, the secondary map probably fills a lot of empty space. So if we look at the insert of a secondary map, it's probably going to allocate based on the distance between two values. Is it possible to have if else below a V stack? Feels like a bug, but not sure. Yeah, it certainly is. You certainly can. Hello, Ollard. I'm all right. How you doing? Apparently this isn't working now. Unable to connect. Okay, so I'm guessing this is pointing to slot map, which has nothing to do with Dioxys. But I'm sure there's a crate called slot map, and this is what we can look at instead. So let's look at the documentation. Let's see if there's a sparse secondary map. There is. So, okay, this is really what we're looking for, right? So I would venture a guess that inside this secondary map, there is something very similar to a slab. And when you do an insert or a set, is there no insert? There it is. When you do an insert, it's going to allocate between the keys, right? Yes, this is it, right? So it's going to extend all the values that is there. And this is very similar to anathema's secondary map, right? But a sparse secondary map is just a hash map in that case. But that makes me wonder. All right, that makes me wonder. Yeah. Now, so we thank you for the cheer. Thank you so much, Ollard. So we actually have generations in Anathema as well. So if we go to the store and we look at the slab, there is a generational slab. And here, the key is actually encoding the generation into it. So we have 48-bit numbers for the keys and 16 bits for the generation, right? But we don't store them as two separate entities. Instead, we encode everything into one U64, right? But yes, any hoodles, oodles, or poodles, the sparse map is what I'm wondering if we might want. But this one just seemed to be a hash map. Is this a hash map based on the standard library's hash map? Because the key, it is. Because the key is a number, and that makes me think that there are faster ways of doing that. Interesting. So it's a trade-off, right? If you don't have a lot of values, then a vector is going to be faster. most likely. That's okay, bean juice. But I prefer messages that are written by people, not just because it's more personal, but because LLMs add a lot of craft that says nothing, right? So you get like a lot of unnecessary things to read that holds no substance with a lot of the LLM generated stuff, right? Well, thank you, Bean Juice, and I hope you do feel appreciated in between all the cussing. It's just index access? Yes. Well, the index comes from somewhere else. That's why. So a secondary map is most likely associated with a primary map or a slot map or a slab, or call it whatever you want, right? So you end up with inserting something into a slab, getting the value out, and that's the value that is being used here to store it, right? So in our case, this would be the widget ID. So instead of expanding a secondary map to fill it, to fit, we end up with just a hash map, right? This is a painful journey, to say the least. Hard to keep track of true and false. I feel like that statement is false. So we could use something like a sparse secondary map for what we're doing. I'm a little bit uncertain of what the key is being used for here. What is the point of K? So this thing will never do anything. The only thing that's saying that this is a function pointer that takes K and returns K, right? That's all this is saying. But this never exists. I don't know why you wouldn't just put K in there. Why would you use a function pointer? I wonder if there's a justification here. A K is just a generic type. It's not really relevant what K is, as long as it has an additional type associated with it, right? And since phantom data is a zero size type, I don't know what the value of doing this is. It strikes me as odd, but yeah. If it was to make sure that K is used, then why not just make this generic over K? Why even have that? Neither can I. So you can use the phantom type in the way that we did in the previous example, where I make it a const t or a pointer to t, which not only enforces the use of the type, but also prevents the wrapping type from being sent across thread boundaries, making it effectively not send. But this, I don't get. Are function pointers not send? Is that what they're doing? Function pointers should be sent. We can find out because I have no idea. They are. So I don't know what the point of their code is then. Right. I don't get it. Yeah, but what's the point of the function pointer, Howdy? That is the question. There's nothing in here that says anything about using the function pointer. Actually, here they pass in a key. But that has nothing to do with anything. Oh my god, can you please stop yawning? No. No, I cannot. They're just giving you red herrings? Yeah, probably. Start yarning. I don't know what yarning means. Like make yarn? Spin a yarn? Why do I engage in these conversations? Nobody knows. Okay, so yeah, we don't need to look at this code now. Like a spider. Do spiders spin yarn? I don't think they do. I think they're busy eating flies. Enjoy Temporis. Thank you for the subs. Thank you for hanging out. You and me both. All right. Is anyone up for this, or should we just go and sleep now? Should we just call it a day? We'll go sleep for a bit and then come back. All right. Okay, I might try to fix this outside of the stream then. All right. So we'll raid. Please feel free to ping me on Discord if you do Temporis. I might need the productivity. There we go. All right, go and give Temporis a follow. And then we'll... Okay, that shadow might not have worked now. All right, anyway, bye. Oh, Twitch. I guess we're staying here for a while longer then. All right, we'll see if we can reload this thing. Oh my god, this isn't working. Okay, well, go and watch Cakes. I can't even send this message. I can't send any messages. Okay, we're back. We're back. Hey, there we go.